In this stream, we're going to be definitely diving into essentially all things about overclocking for 13th gen series based processors. So while our demo system is going to be utilizing the 13900K, the overclocking insights are going to definitely be applicable to the 13700K, to the 13600K, and actually to a degree, even if you were to attempt to run these CPUs on Z690, you'll still essentially have kind of these insights. Now, one of the cool new features that we also will be demoing, specifically the new dynamic OC switcher technology, but for cache, is going to be right now on Z790, so just keep that in mind. But we're going to be talking about overclocking for the CPU. We're going to be talking about a little bit of cache-based overclocking, some general overclocking insights that you're going to want to keep in mind, and then we'll also do a new DDR5 7200 MT Xmp-based demo, just to be able to show you the impressive range that we have for this generation when it comes to the overall IMC, or the integrated memory controller. So some pretty sweet stuff. So overall, looks like we've got quite a number of people joining us here for the stream. We've got Black Chaos, we got Pidgey PCs, we've got SMT Productions, we've got Bane joining us, of course, Sue Min, Derek, and quite a number of other people. So thanks so much for joining us here on the stream. So looks like somebody's already got the 13900K, but no Z790 Apex. Yes, the Apex is a fantastic board. It'll be coming in the not too distant future. If you're definitely interested in overclocking, then that's going to definitely be a board for you. The board that we will be using will be the Maximus Z790 Hero, but overall the overclocking expectations should be pretty similar between a wide number of the motherboards. The only difference is that not all of our motherboards will feature ASUS AiOC. So let's get ready to go ahead and just jump straight into it. All right, guys? Lewis, we will be talking about actually running 4DIMM configurations, but if you haven't actually watched our DDR5 Insights video, which helps you better understand that actually there is no 4DIMM XMP that exists for DDR5 because there are no 4DIMM kits, that is a really good primer that you want to start off with. But we will be talking actually about better understanding, of course, one DPC, one SPC based configurations are essentially 2 DIMMs versus 4 DIMMs. And if you are looking to run 4DIMM configurations, there is actually even better scaling performance, but it's an actual misconception in terms of saying that you would want to run 4DIMM XMP because there are no 4DIMM XMP kits. So really what you're trying to actually find out is what is the type of scaling performance that you might have in a mixed configuration of memory when you're running 2 DIMMs, essentially 2 DIMMs per channel, 2 slot per channel, or essentially 4DIMM configuration. Okay, so let's get ready to go ahead and jump into this, guys. And if you have any questions, feel free, go ahead and drop them in the chat. I'll do my best to go ahead and cover them. If everybody also, I don't remember whatever I set the volume levels to on this, guys, so if you can let me know if the volume levels sound good, that would be great. All right. So we're just going to go with a little bit of kind of just basic primer right here before we get into it. We're not going to spend too much time on this because I think probably for most of you, you're probably pretty much aware of this. But what is overclocking? In short, we're essentially looking to be able to take the performance of different parts, right? So that could either be your CPU, it could be your DRAM, it could be the cache that's on the memory, essentially different frequencies that are essentially for those different components, and looking to move them beyond their base frequency, right? So if we go ahead and let's just bring up the chart that we have for specifications from yesterday. If you guys didn't kind of check out our stream that we did yesterday where we highlighted kind of Z790, the CPUs, and kind of the product stack and everything along those lines, then this might be a little bit news for you. But essentially right here, we can see that if we take a look at something like a 13900K, of course, has a up to 5 gigahertz frequency, right, to 5.8 gigahertz. Now that's going to be with thermal velocity boost, right? That's going to be in the best case scenario, pretty much limited to 1 thread, right? Of course, when you're in an all-core thread, you would also have a different frequency. But essentially, overclocking just means that we would be targeting a higher frequency than this. So already a little bit of a spoiler, I can tell you that right now it is going to be realistic to see 6 gigahertz plus based overclocking on 13th gen series parts. So this is really exciting. It's the first time that we're entering into this space to actually be able to see 6 gigahertz overclocking in real world cooling configurations on a mainstream desktop platform. So this is pretty awesome to be able to have essentially this level of performance available to you in terms of performance tuning. So pretty cool when we talk about that. So again, nothing too complex. Essentially, all we're looking to do is be able to take the performance envelope for whatever parameter we're looking to tune. So again, this could be the CPU frequency. We can overclock that. If we talk about the DRAM frequency, we can also overclock that, right? If we wanted to overclock the cache, we can overclock that. And also keep in mind that for Alder Lake, when it introduced, of course, the E core and the P core, you can actually overclock the E cores and you can overclock the P cores. And there are certain other relationships that you want to keep in mind that depending on how you actually define the operating parameters for your E cores, they can actually influence the P cores, right? So, you know, we'll spend a little bit more time to hopefully get into this and help you better understand this, but we just wanted to go from that basis of what is it, right? It's essentially just taking the operating parameters and driving them further. And for a baseline, again, for those that are interested in the DDR5 specification, remember to keep in mind that the DDR5 specification has been improved this gen, right? So we've gone ahead and moved up from the baseline of 4800 megatransfers to, as we see right here, 5600 megatransfers. But again, spoiler, just like I talked about 6 gigahertz overclocking being a reality for 13 gen series processors, the new normal for most 13 gen series CPUs is going to probably be upwards of 7000 MT, especially when we're talking about 2 DIMM configurations. This is absolutely monstrous when we talk about the level of overclocking capability that Raptor Lake is bringing to the table, when it not only comes to impressive clock speeds for the CPU, but really impressive clock speeds when we talk about the DRAM. Okay, so hey, Erica, happy Friday. Thanks for joining us. Hey, Miguel, also fantastic. Thanks for joining us here. So very, very cool to have you here. Oh, hey, DePoets. Thanks for joining us, man. Fantastic. So we got a water cooling enthusiast there. So definitely we know that we've got, of course, overclocking in mind when we're looking at somebody like him. All right. So what are a couple of things to keep in mind before we get into the overclocking pieces? Of course, you know, some of this is going to be pretty straightforward. The most important thing I'm really going to say is that, of course, you want to make sure to have a performance baseline. And so I'm going to bring up a moment here, a little bit of what I call my overclocking insights, and these are going to be specific to 13 gen. But you want to, first and foremost, create a baseline. The baseline is going to be representative of performance, power, and temperatures. And so that what means essentially is that once you get your system up and running with full UEFI defaults, you want to go ahead and run, you know, general stress tests. You could use an application like OCCT, you could use Cinebench, you could use Geekbench. You want to use a few different programs, and you want to be able to go ahead and track your temperatures. And we'll jump into the desktop environment to kind of show you how you would kind of go about this process. But you want to create your baseline. And this is important to just be able to make sure that you can have a measurement, right, to see where you're going to be increasing, whether it's going to be increasing your thermals, increasing your power consumption, as well as hopefully increasing your performance and your clock speeds, right? Because if you don't have a baseline and you start to make changes and you don't have anything to compare and contrast, it can be a lot more complicated to really know if you're actually really seeing an improvement, right? So that is just something to keep in mind. So let me go ahead and bring up some of the insights that we're going to be jumping into here. Give me 1 second. All right, and I'm going to go ahead and bring these up here. All right, perfect. All right, so let's go ahead and kind of break some of these down here. All right, so here are kind of some of the overall insights you want to keep in mind when we're talking about overclocking 13th gen, right? And this is applicable, of course, to Z790, but of course, the overclocking experience is going to be pretty similar between Z690 and Z790. Z790 does have a little bit more of an optimized signal integrity design, especially for higher frequency in terms of DRAM. This is going to be a little bit more in the margin cases in terms of just supporting some higher kind of frequencies, but the overall experience should be pretty comparable to the two, whether you're talking about DRAM or whether you're talking about the CPU, but there's a little bit of kind of optimization that we've done in terms of Z790, just because, of course, you could take lessons learned, fine tune that, and maximize scaling performance, right? But that being noted, 6 gigahertz is possible. So that's really one of the big things. Many of the CPUs we're going to be seeing essentially between about 6 to about 6.2 gigahertz available to you when you talk about 1 to 2 cores. So especially because lightly threaded applications, especially games, can benefit from frequency, this means that we can help to really push beyond that base target that Intel is offering at 5.8. The 5.8 is also a little bit conservative in terms of how it ends up effectively being reached, because there are, of course, certain parameters that are consistently tracked that define how the actual CPU is going to be boosting, right? And so when we overclock, we can essentially help to increase some of the parameters that allow essentially for the frequency to be more consistently boosting to higher values. So not just across 1 to 2 threads or 1 to 2 cores, but across more threads, more cores, right? So this also means that as a whole, we can have a little bit more of an uplift. An example of this is the baseline kind of default parameters for Intel would generally have about all your cores under full load be about 5.3 gigahertz. But once we overclock them, we can easily uplift that, you know, to 5.5, 5.6, 5.7 gigahertz across all those cores. And then, of course, as we move into a more per core overclocking model, so per core meaning that as we go from kind of a broader set of cores to a smaller set of cores to maybe 1 or 2 cores, right, we can keep bumping up the frequency. And this is important because a lot of people will sometimes do what's called a static overclock or an all-core overclock. This is a really limited way to overclock your system because you're going to leave frequency on the floor. And we don't want to do that. We want to really maximize the overclocking headroom that the CPU has. And so per core overclocking is the best option to allow us to kind of get the best of both worlds, where we can have an all-core based overclock, but we can also take advantage of the lightly threaded overclocking headroom that's available to us, right? So again, 6 to 6.2 gigahertz on the cores. Keep in mind that there is a difference in terms of the loading. So light loading versus heavy loading. If you're talking about heavier loading applications, then you're going to bring that frequency down. It's not going to be as aggressive. It's not going to be as high. So if you're somebody that's more in a professional workflow and of course you're heavily hitting that, then that's not going to be realistic. But if we're talking again about, I'd say, normal desktop usage in gaming, these type of frequencies will be possibles. Okay. E-cores, they can be overclocked, and we're going to be talking about frequencies, between about 4.5 to about 4.7 gigahertz. Now, keep in mind that the numbers that I'm giving here, this is a general kind of range, right? There is still something that is called the silicon lottery. So I call it personally silicon variance. It just essentially means that every CPU has a different level of margin within it. But as a whole, we generally have a rough guesstimate to know to a degree, what's the overall kind of realistic average that we can see, at least for a majority. This doesn't mean all CPUs. You may have a CPU that may not be able to hit some of these targets, and it might be a little bit lower, right? It might be a little bit of a hotter CPU. It might have a CPU that runs at a little bit of a lower frequency and can't hit some of these values. But generally, these are going to be, in a lot of cases, going to be achievable targets. And I would probably say that's at least, probably upwards of, 70, 75% of cases, you're probably going to be looking at this. Similarly, again, you keep in mind that light loading versus heavy loading is going to be a factor, right? Another factor is, I'm sure that you guys have seen maybe some of the media reports as far as the temperatures. These systems can definitely consume, 300 watts, over 300 watts, right? That means that it can be a lot in terms of thermals. But the reality is, again, from a thermal perspective, you can definitely cool these systems with normal cooling solutions. So you don't need to go custom water cooling. You don't even need to have a 360 radiator AIO solution like what we've got here with the Ryuo Gen 2, or what I'm going to be using, which is our new Ryuo 3, which is featuring an 8th gen Asetek pump. You don't have to use that. If you've got a 240 millimeter, 280 millimeter AIO, you can still overclock and still have very good temperatures, but you have to keep in mind your workflow, your usage. If you're talking about no more desktop use and gaming, you're going to be entirely fine. But if you find yourself that maybe you're really consistently heavily using a 3D rendering application, heavy compute applications, applications that are heavily doing decompression, you're probably not somebody that's focusing on overclocking, because overclocking can, of course, lead to instability. It consumes a lot more power, produces more heat. So you're probably just going to look to get the best performance that you can from stock. So maybe you'll still take advantage of DRAM overclocking, because that won't really that won't really influence your CPU temperatures, but it's still a factor, right? All right. The IMC, sorry, a little bit of a mistype right there, but the IMC is improved, and so 7000 MT is kind of the new OC normal, especially when we're talking about two DIMM configurations. So if you guys haven't checked out the PC DIY group, we have a great community post that I have that's called DDR5 Insights, and it helps you understand that actually the vast majority of CPUs were generally able to achieve about 6000 to upwards of about almost 6400 MT, and so that was going to generally be in a 1 SPC, 1 DPC, or essentially a 2 DIMM configuration. That would still be applicable on 4 DIMM based motherboards. But now we're seeing that jump up considerably, that 7000 is fairly conservative. We expect the majority of CPUs to be able to target in this, and actually a pretty good amount of them are going to even be better than that, where you're going to start seeing 72, 7400, 7600, right? I would probably say that maxes out probably around 7200. From there, better quality IMCs, so a smaller percentage and definitely not all, and very similar to kind of like 12th gen, where we saw a cutoff that after about 6000, 6200, as you got into about 64 to 66, you started to see what we call a kind of breaking point, where there was definitely some IMCs that could not run at those XMP dividers, right? And that's not a fault of the motherboard. It's not a fault of the MRC. It's just a limitation of the memory controller. You're talking about a big overclock jump, right? From that like 4800 all the way to 66. But here, we're going to see that now that breaking point is going to be closer to between about 74 to about 7800 7800 megatransfers. That's pretty crazy that we're going to be talking under air-cooled configurations. You could be looking at 74 to 7800 megatransfer overclocking for a very good IMC. That's not going to be the standard. For the standard, though, many users will be able to realistically look at 7000 MT plus in terms of that. Okay. So pretty sweet. And then the last thing is that maximum performance is not just about overclocking the CPU. You're going to be looking at really wanting to maximize multiple parts of the platform. You want to be able to maybe overclock the CPU. You want to overclock the cache. You want to overclock your E-cores, so E-cores and P-cores, and also you want to overclock your DRAM. So all of those can be overclocked, and they all influence the overall OC experience, right? So that's just some of our initial kind of primers that we have in some of the insights. Of course, we've got our demo system. I'm going to get it up here in a little bit and we'll walk through that, but we've gone through quite a bit here. So I do want to quickly just take a look here and see if we have any kind of questions from the community on some of these points before we get into this stuff. So let's just see here if we have anything. Okay. So Tech says, I'm running 6600 just now on Z690, which posts at 7000. Yes. So there's a big difference between, of course, posting and booting, right? So realistically, I would already say that if you're running 6600, your IMC is already higher than the norm. Most users, they have what I would refer to as an anecdotal kind of type of value proposition in terms of how they value whether or not their IMC is good or not, because they just don't test that many CPUs, right? Internally, we can test hundreds of CPU samples, so we have a much better kind of data set to really kind of know where the margins are at. But that is pretty cool. If you've got 6600, that's quite impressive in terms of the overall memory controller that you're running. But like I said, the big thing here is that we're going to be seeing a much nicer uplift in terms of consistency. The consistency of users can be far better here at being able to not only just hit the entirety of almost about the 6000 MT range, right, which in itself is really impressive, but actually then move into 7000, right? So Ken K says, hey, how you doing? Champ A320 is asking, what's the max speed of RAM with the BIOS 2103 on a Z690? Can you run 7200 like you can on Z790 motherboards? That's going to not be really influenced that much by the motherboard. Although, like I said, the signal integrity is a little bit better on Z790, so it's been tuned a little bit more tightly, right, to be able to be superior. It's going to be more influenced by the IMC. So we're still doing some final follow-up analysis to kind of take Raptor Lake and put it on a Z690 series motherboards. You should expect to see an uplift in terms of the scaling support. So if, take for instance, you had a Z690 series motherboard and you saw that wall where maybe you had well, right now there's very few. I don't even think there's any mass majority market kits right now that are in that 7200 kit that you can easily purchase. But once those start to kind of come into the market, right, if you were to drop that on there with 12th gen, it's pretty much not going to post. It's not going to boot. You're not going to have stability, right? But if you were to drop in Raptor Lake, you have a high probability that you're going to be able to see a better experience, right? So that's that. Let's see, Felix is saying, will there be 128 gigabyte 7600 MT DDR5 kits? That's TBD. Right now, I wouldn't expect it because, of course, a lot of the tuning is really focused within the traditional density. So that's going to be, your 32 gigabyte and 64 gigabyte kits. And anything that's really going to be over 7000 MT really is going to be focusing probably on 32 gigabytes. And then, like I said, there'll be a small kind of select level of binning that happens for 64. 128, because you're also at this time in the future, we'll be able to get to 2 DIMMs that are running 128 gigabytes in DDR5. But realistically, I'm going to say for 128 gigabyte configurations, you're probably going to be looking at 5600 MT being kind of the normal. There will be even a little bit better experience than that. That's already an improvement compared to Z690 and 12th gen. 12th gen with 128 gigabyte configurations, you are generally going to be looking at a closer value of probably somewhere between about 48 to about 5200. So there is a little bit of an uplift, but keep in mind, I don't have the port table right here up in front of me for 13th gen. But for reference, why you need to understand this, right, is this: if you take a look at the Intel DRAM table, right, you can see right here that when you go to essentially such high densities like 120 gigabytes, the default speeds that are supported are going to go down. So you can see, as an example, like on 12th gen, 4800 was supported in those one SPC, one DPC, one rank, two rank configurations, right? But as you got to either higher ranks or essentially more dense configurations like 4 DIMMs, you're dropping down to 44, you're dropping down to 4,000, you're dropping down to 36. So you have to keep in mind that already that bump from going from like 36 all the way to 48 or 5,000 or even 52, that's actually quite a bit of a jump, especially it's more strenuous to the IMC when you're doing it with a very high density configuration. Okay. All right. So let's go ahead and see right there. Somebody's asking Kingston 6400. Yeah, 6400 would be no problem on Raptor Lake. That's easy peasy, no problem. All right. Will we ever see 4 DIMM kits? That's really up to the memory manufacturers. Right now, there's not really any point to making them, to be honest. There's not a lot of value, especially for gamers, right? The only people that need 4 DIMM kits are going to be professionals, people that actually require high density. And those users, like I said, they generally don't usually try to focus on overclocking because you're introducing instability, you're shortening lifespan, you could even be affecting, of course, warranty, right? So the reality is that for those users, they prefer stability. So if you were to see 128 gigabyte kits or native 4 DIMM kits, my expectation is, one, is they're going to be lower, but then also they're going to be really focused towards a different type of the market now, really kind of the general enthusiasts. It's all about performance, right? And so I think in that regard, the 2 DIMM configurations, like they've always been for DDR4, for DDR3, it's always going to be better. Okay. All right. So see, any other quick questions before we get to the next point? If not, we're going to keep moving things along there. Martin's asking about estimated release date for the ProArt in the not too distant future. I don't have any specifics yet. Probably going to be in November some time frame. If you're part of our PC DIY group, you'll get the notification to let you know essentially when we will be essentially releasing it to the channel. Okay, so let's go ahead and quickly get a recap here of just some of the last points before I go ahead and throw up my test bed. If you guys got more questions, feel free to go ahead and drop them, and we're going to get ready to start doing some overclocking and kind of run through some of this stuff, right? So as we're going into this, right, so again, CPU, DRAM, OC insights, and an important part when we go into overclocking is ideally you want to approach overclocking with an asynchronous mentality. And what I mean by that is some users will overclock the CPU, overclock the DRAM, and overclock the cache like all at the same time. And then something crashes and they blame it on one or the other, or they don't know what's going on and they get frustrated, or they say something is an issue and it might not really be an issue, but you have no idea because you've overclocked them all at the same time. It makes no sense. You really always want to pursue what is referred to as an asynchronous overclocking methodology. So that means ideally you want to overclock your CPU independently first. You then want to see what that maximum headroom is, right? You then want to overclock your DRAM independently. That means leaving your CPU generally at stock. And then even your cache, if you're attempting to overclock the cache, you want to overclock the cache just by itself and see how it responds. And the main reason why you do this is to find out kind of what the peak headroom for each one of those is, right? Once you understand what those maximums are, once you begin to kind of combine the permutations of the overclocking parameters together, you'll actually find that a lot of times, because it can be quite strenuous for the CPU to run those all at one time, some of those values are going to come down. So an example is, let's say maybe my IMC can run like 7600 MT, okay? And my CPU can run like 6.2 gigahertz, right? But when I bring them both together, maybe that value is going to come down a little bit. Maybe it's going to be closer to like 7400 or 7200 in the memory, and it's going to be 6.1 on the CPU. So this is important because you first just want to ascertain your maximums, right? Once you ascertain your maximums, then you want to start kind of bringing them together. And even bringing them together, ideally, CPU first, DRAM next, and then from there, your cache is going to be last. Cache is really kind of that last resort because it's quite sensitive, especially with the way that it works within eCores. You generally don't have to do it, but there's a cool feature that will show you that allows you to kind of even get more performance if you want to take advantage of it in this generation, which we call our dynamic cache switching technology, which we have as part of our options inside the UEFI. Okay. All right. So that gives you some overall baselines there. All right. So let's go ahead and get ready to start here on our overclocking. All right. Let me see. Quick question right here. Kaylin is asking, can you remap the flex key button for power on? No, you cannot. Part of this is because there are some specific limitations in terms of the way that the controller that works with that functionality works, right? It's something that maybe we could discuss with our team, but as at this stage, no. The options that are available to you are essentially already present within Uefi in terms of what you can set the actual flex key functionality for, but right now you cannot use it as a power off and on function. But I definitely understand the value add. It's actually something that we've already discussed internally with our team, because I know that kind of when people set up a small form factor system, they might have it maybe over a little bit off, and then if you have the Hive right there, it would be cool to just be able to kind of touch the button right there, as opposed to having to maybe reach all the way over to your system and then click a button or something like that, right? So trust me, I get it. It is something that kind of we're evaluating, looking at, and it's very similar to the knob function on the Hive that allows you to adjust the volume. We're also looking at that to potentially be able to control fans, right? So if we make any of these adjustments, we'll definitely detail them in the PCDIY group. We'll talk about them in our weekly stream, and they'll be issued most likely with a firmware update and a UEFI BIOS update. So as always, just make sure to keep it in mind. If you're checking us out either in the group or the weekly streams, you'll find out about those updates. Okay. All right. Somebody's asking about the Ryu 3. I'm going to be busting it out in a little bit right here because that's on my test bed. Let me go ahead and take one more question before I start pulling some of this stuff out right here. So give me a second right here. Tracy Fox is saying, as I just received my Z790 Hero, thank you for being Team ROG and Team Maximus in the mail. Looks great. Do you know if there are going to be any mono blocks coming out from EK? I can't tell you that for certain. I would say reach out to, EK. We have both EK representatives in our PCDIY group. You can reach out to them. Jake and Attila are both part of our group, so they can definitely help to respond to that. My expectation would be yes, almost always partners do produce mono blocks for the Hero because it's pretty much the most popular enthusiast board that's out there on the market, so it's very common to see mono blocks. You don't need a monoblock. I know it looks really cool, but the reality is you don't need it because the VRM runs super efficient and the heat sinks are very high performance. So from a thermal perspective, there's zero really value to kind of put a monoblock on there. But I know a lot of people like the monoblock just because it looks really cool, right? All right. See, any last question right there? Simon, is there any difference between the Z790 Hero and the Z690 Hero? There actually are a couple of little differences. They're not dramatic. I will go ahead and actually answer that a little bit later if I can, because I want to keep things focused on here, and that would take a little bit of time. But if you go watch the first look preview that we did on the Maximus Z690 series, on the Z790 series, I did compare Z690 to Z790, so you should have an understanding of the differences from kind of gen to gen. Okay? All right. Quick question, will there be an ROG Maximus Apex this time? Yes. If you didn't watch our live stream yesterday, we already announced it, but I have the board over here, but I don't want to run to the other room to go get it. So I'm just going to show you a picture. So let me show you this beautiful board, and let me go ahead and get my test bench set up here. There you go. Look at that beautiful board. That is the Maximus Z790 Apex. It is going to be the only Maximus board that we will have in white. I know some people have asked, hey, are we going to have a formula? We are not going to have a formula this generation. So if you want a white board, the Maximus Apex, the Prime Z790-A, or the ROG Strix Z790-A DDR4, those are the three motherboards that we have that would be kind of enthusiast focused, because we have a couple other Prime series motherboards, but they're going to be a little bit more entry. Okay. All right. Let me go ahead and just start getting up my little test bed over here, guys. So give me 1 second. Feel free to go ahead and drop in your questions right there. I'm still paying attention, but I have to get this test bed set up right here. Okay. So again, if anybody's wondering, test bed that we are going to be using for this is going to be the Z790 Hero. Overall, most of the results that I'm going to show you would be applicable to other boards that we have within the lineup, so you don't necessarily have to feel like you have to go with the Hero. The only thing is that keep in mind for the Asus AiOC technology, when I do demo that is only applicable to boards that have Asus AiOC. So that would be like ROG Maximus, ROG Strix boards, the ProArt motherboard, but Tough Gaming and Prime don't have Asus AiOC. They still allow you to manual overclock, but they don't have this Asus AiOC technology, so do keep that in mind, okay? All right. All right. Cooler wise, in case anybody is wondering, this is the cooler that I'm going to be using right here. This is the brand new upcoming Ryu 3. This is the kind of follow up to the Ryujin. It doesn't replace the Ryujin because, as you'll see, it's going to be a circle pump head versus the square pump head, and it's the anime matrix display as opposed to a screen. So the screen allows you to have kind of full GIF animations, images. It's pretty much a screen, right? And you can also have 4 different quadrants of information through the Armory Crate or even AIDA64 integration. This will utilize the same type of pixel editor that we have for the anime matrix on the motherboard. So it's a little bit of a kind of more stylized pixelated graphics. It's really cool. But this is also using the 8th gen Asetek based pump design. So there's actually quite a number of improvements in there. It's a 3-phase motor. It's actually got more internal liquid. It has an actually square base plate. It's larger. So it's a little bit higher performing. So it's a little bit more kind of targeted towards this latest generation of CPUs, right, for both 13th gen and, of course, Ryzen 7000 series. But Ryujin 2 would work great for overclocking. The ROG Strix LC2 series would also be great. And, of course, if you got water cooling, like, I don't know if the Poets is still here, if you got a block, throw the block on there. And the block is, of course, going to make you happy because you're going to have some low temps. All right, that's what I'm going to be using for the cooling. All right. All right. So let's get my little test bed set up right here. I love blocks. I'm with you, man. I love the blocks too. Yes, I'm definitely a big fan. We'll probably be doing a follow-up little demo to actually show off some of the cool ASUS AiOC functionality with maybe a little bit of a bits power water cooling setup, so you can actually see kind of the delta. Again, it's not super critical. You don't have to do custom water cooling for 13th gen, especially if you're gaming. But I think for those that might be a little bit more of a hybrid user, maybe doing more advanced editing, definitely doing some heavier multi-threaded workflows, and you're going to want to do water cooling and also have high clock speeds, then of course, then you're going to benefit from custom water cooling. That is going to give you an edge. It just comes down to physics, right? You're able to dissipate more heat more efficiently and more effectively. So that is going to be pretty sweet. So if anybody wants to see, I'll kind of show it really quick here. I guess I can show it to you guys. I'll light it up. I'll put it maybe under the secondary. Actually, I'll do that. I'll put it under the secondary camera so you can kind of see it, because it does look pretty kind of cool there. Let me see here. And technically, I don't need a GPU. We'll need a GPU in a little bit, but let me go ahead and just actually throw the GPU on there, because that's the cool thing is that for this setup, I can pretty much just use the iGPU for a lot of the overclocking, but for the kind of gaming load, it will probably make sense for me to throw a GPU on here. So I'm going to put a GPU on here. All right. And got my memory already installed in there. For memory, in case anybody is wondering, this is going to be a 7200 MT kit of memory. I will have an HDMI output, so I'll switch to that, guys, so we can actually see the Uefi environment, so don't worry about it. Even though you can't see what I got necessarily going on here, you will be able to see what I am kind of tweaking and tuning when it comes to that. And this is nothing crazy power supply wise. I have I was using prior to this, just for my other test bed, I was using one of our ROG Strix 1000-watt power supplies. But here, for this overclocking test that I'm going to show you, this is not even. This is just a nice Seasonic Focus, which is not even their highest end series. This is just a 650-watt power supply that I'm using for this overclocking demo. So I know a lot of people are like, oh, I need huge amounts of power. And the reality is, having power, especially for peak transient, can be performant, and it is somewhat dependent on your whole system configuration, but you don't necessarily have to kind of go crazy. This is a 3070 with a 13900K, so this is a little bit maybe a mismatch, but maybe this would be kind of something you're running. For most users, my recommendation right now is either a very good quality 850 watt or 1000 watt. If you're really a kind of high-end user, then a 1200 watt is, you can target that, but really even 1000 watt, even with a 4090 would be fine. Okay. All right. And I'm not even connecting the dual EPS power connectors. I'm going to connect one EPS power connector, but do keep in mind that the CPU power connectors on our motherboards are what I call our ProCool power connectors. So they actually have a thicker pin, so they actually have higher current handling performance. That also helps to actually reduce temperature at the point of contact. So that is also going to be a beneficial item right there in terms of the design. But ideally, if you connect both of them, you do get a little bit better load balancing. So you do ideally want to have both of them connected. Okay. There we go. All right. All right. There we go. All right. We've got it connected here. Very, very cool. All right. Let me go ahead and just see. Got any questions right there that kind of might come up? I'm going to go ahead and just throw it under that second camera so that you guys just want to see the pump housing really quick. You guys can check it out. But now that I've got that set up there, let me see if we've got any other questions that might come up. I wouldn't say that that's a high temp, Yodo. I believe I'd have to double check the thermal junction. The thermal junction temp is actually going to be, I think, 85. It might even be higher than that. So you're actually well under that. And keep in mind that temperature on the chipset is actually going to vary for multiple factors. One, you have your ambient temperature consideration, but you also have IO saturation. So the more that you adjust certain elements in terms of the IO, or you use the IO bus, you'll see an increase in the temperature. So you can have very different levels. You also have something that's called heat pooling, right? So depending on your GPU that you may or may not have, that heat can actually radiate from the GPU and actually saturate onto some of the other underlying components. But the temperature reporting, I wouldn't worry about it at all. It's not an issue. All right. Tara's asking, I have a tough 4090, 1000 watt PSU. Yep, 100%, no worries. Keep in mind the transient response, the demands essentially in terms of peak power for the 4090 are actually less than they were even for the 30 series. So overall, you don't actually have to worry about it in the same regard. So you're entirely okay in that regard. Okay. All right. Okay, very cool. Let's go ahead and keep going along here. Is there any difference between the Z790 versus Z690 as far as the memory controller? So yeah, Philly, I just talked about that a little bit earlier. If you kind of go back and scrub in the video, technically it's not Z790, Z690 because there's no memory controller on the motherboard. Motherboard, we did do a little bit of signal integrity improvement on Z790 versus Z690, but the memory controller is inside the CPU. And for Raptor Lake, yes, there is a big uplift. Overall, you will see a significant uplift where, as I noted, essentially kind of 7000 MT plus is the new normal, especially for 2 DIMM configurations, compared to 6000 generally being kind of the normal for overclocking range under 12th gen series processors, right? Okay, so let me go ahead and just move this over here. You guys can kind of check it out quickly if you want to see the little housing. Then I'm gonna have to move it back over here. Let me go ahead and get this loaded up here. Might need to switch out this battery. Give me 1 second, guys. All right, and get my HDMI cable. All right, here we go. So essentially, will the QVL of the Z690 Apex be updated for the 13900K? Most likely not, but that doesn't mean that you won't see improved memory controller performance. Keep in mind that you can also see updated QVL information directly from the memory partners. And an important part that you always want to keep in mind for the QVL that a lot of people forget is that the QVL is a reference from the perspective that it shows you what's possible, but it doesn't account for the quality of the memory controller. So right now in the QVL, we have memory kits that are on there like 6800 MT, right? But there are plenty of users that will not have that be possible in terms of a Z690 motherboard. And part of the reason for that is that their memory controller is too weak, right? But it's very difficult for users to understand that because they don't have 10 CPUs. They don't have the ability to go from one CPU to another CPU, another CPU, and all of a sudden find out, wow, the limiting factor was my CPU was weak, right? Now, if you're talking about generally a lower value, this is usually not a factor, and you can kind of go with the QVL to feel more comfortable or confident if you want, but it's not really that important, if that makes sense, right? Generally, the interoperability across memory manufacturers and more importantly across the different types of ICs is very good with us, whether it's Micron, SK Hynix, or Samsung. But the bigger part is, especially once you start to go to higher and higher values, even if you pick a QVL kit, you have to really understand 3 things. One is the density in the population, actually the correct configuration, or did you mix it? Because some people go, oh, it's on the QVL, let me buy 2 of them, and you broke the QVL because you're running a configuration that wasn't designed to be run in the first place. 2, it's a frequency that is at a higher likelihood of not being successful, right? Or a lower likelihood, it just depends on how you want to phrase it, right? So those are kind of 2 things that you want to keep in mind there, right? All right, so let me just go ahead and kind of show here. There we go. All right. I think you guys should be able to see that. So there you can see it's got that kind of cool little like pixelated display. I can't show you all the customization because I don't have even the final firmware for it yet. But the final firmware, of course, we'll show this later in a launch live stream, and I'll have it all set up kind of in a build and you guys will be able to see it. But you can see that's nice kind of cool circular pump housing with this kind of little pixelated graphic design. Pretty sweet, overall cool in terms of the kind of the design aesthetic. I really also like that there's no cable that you have to attach to the Ryu. So normally I have a little micro USB cable. The micro USB cable is already directly connected to this pump housing. So you pretty much just connect the USB cable and you're good to go. So it's a much more streamlined, tight, clean level of integration right there. So, okay. All right. All right, let me go ahead and power this up, guys. Somebody's asking, is there a difference with DDR4 speeds between Z690, Z790? Again, I'm assuming you're talking about 12th gen to 13th gen because the memory controller is what dictates kind of the speeds. So technically the official specification support is the same. It's 3200, right? But I will say there's probably a little bit of an improvement in terms of some Gear 1 scaling. You still have Gear 1 and Gear 2 scaling that is going to be present, right? That's true for DDR4 and for DDR5. But I will say that there is probably a little bit more margin within Gear 1. So if you're somebody that kind of wants to run a little bit of a tighter level of performance, right, for, you know, maybe you have like a really good 4000 kit of memory. Generally, you weren't able to run 4000 within Gear 1, so you're going to have a little bit more margin to be able to do that. We're still doing some final testing with some of the new MRC in that regard, but I'd say yes, you get a little bit of additional margin within DDR4. Okay. 13th gen is, no, it definitely is not. I'll show you right here. It's definitely not hot. I can run it at 6 gigahertz with that overclock and gaming, and I'm going to be fine. You know, I'm going to be, depending on the game, you know, between like, you know, 55 to like 75 degrees. So for me, that's entirely fine. If you think that's hot, I'm not sure what temperature target you kind of really want. Now, if you're somebody that's going to run sustained multi-threaded workloads, you know, any modern processor really for recent memory is going to run actually, you know, generally at high temperatures, right? If you're going to run them under sustained loads, right? But it all comes down to workload, okay? Yato is asking about i225. There is no i225. If you watched our live stream yesterday, or you watched our other first look previews, or you watched the group on the post, all the boards feature the new i226. So there is no i225. And also, for most people that generally experience an issue, that was very early on with version 1 of the i225. We didn't actually even use version 1. All the latest boards actually all use version version 3. And then also Intel did issue drivers to help to improve interoperability and compatibility with different switches, which tended to be kind of, I would say, where people might have experienced factors. So overall, shouldn't be a factor. Okay. All right. Go ahead and get this over here. Yeah, I've seen reports of that. I'd say if you have feedback, send it to Intel, you know, and they can do debugging, or if you want, send it to our team if you can consistently duplicate it on one of our boards. But I can tell you that our own networking team, we're one of the, of course, only motherboard manufacturers that has a full networking division, because we have a world-class, actually, networking product line, and we actually test multiple protocols, including actually IPv6, and we do use that as part of the evaluation testing, and I haven't seen any of that in my at least testing, but like I said, if you have feedback, feel free to go ahead and send it to us. All right. What am I missing here? Let me get this keyboard connected here. So Toolless Tech, sorry, here is saying, what? Can you please test a 2-core overclock without HT if possible, and see if one hit 6 point gigahertz is higher? I already Toolless Tech. If you didn't, I don't know if you were here for when we started the stream. I already actually highlighted it as already possible. You don't need to actually disable HT, okay? But we'll be showing that in a little bit. So If I already noted this right here. So 6.1 up between 6 to about actually 6.2 gigahertz is actually going to be possible on 1 to 2 cores. You don't actually have to disable E-cores to achieve that. There is, of course, a proportional relationship that if you do disable E-cores, you can sometimes extend the P-core overclocking margin, and there is also sometimes a relationship in terms of voltage. But overall, I wouldn't do that because you'd be leaving so much performance off the floor. I mean, one of the really big things now is taking advantage of those E-cores. And also the way that kind of thread director and the managing works, there's some interesting parameters there. And so this is why I think, again, the best case scenario, if you want to kind of maximize performance, it's going to come through the balancing of taking advantage of not only just the P-core overclocking, but also that cache overclocking. And as I noted, actually taking advantage of the cache-based overclocking, but cache-based overclocking that is also linked to current, because cache is very sensitive, and if you actually drive the cache too hard with the E-cores, it can cause instability. So we have a new feature that will allow you to essentially dynamically switch the cache ratio based on actually current handling. So we'll be showing that in a little bit here. I turn off E-cores, thought it's better for gaming. It can be. It's not better for gaming. In most scenarios, you're already going to get amazing performance in gaming. But if you're talking about having the highest clock speeds, absolute highest clock speeds, you can potentially sometimes eke out a little bit more margin on 12th gen. But as I noted, that 6 gigahertz, 1 to 2 cores is already possible without disabling the E-cores. So in my opinion, why disable the E-cores if you can hit that frequency without disabling them, right? Because you're going to get more performance, right? Why give up that performance? Because some games can actually sometimes benefit from those E-cores. Okay. All right. Is there any memory training on 13th gen? There's memory training on every motherboard. If you didn't have memory training, you would definitely have some issues. You definitely need memory training to occur, so there's always memory training. Depending on the complexity of the memory and the scaling, you may have a little bit longer memory training. You could have a little bit shorter memory training, but overall, the Raptor Lake memory controller is very, very good. So training's pretty quick. It's quite shorter than comparable like AMD platforms, even at higher MT values. So it's not something I would really say that you have to be concerned with, but there is always going to be elements of memory training. When you kind of go from one value to another value, the board has to kind of calibrate to that, and the IMC has to calibrate to that. All right, let me go ahead and switch over, guys, here. I think I should have this here set up. All right. All right, we should be, I think, good there. If you guys can let me know if that maybe, does that work better there if I keep it in the bottom right-hand corner? All right, let me see right here. What's the question? Hold on, let me check this others. Yeah, that should be correct. That should be that system. Okay. What about the Maximus Z690? Z690, I'm not sure what you mean in terms of relation to your question. If you're asking about like the delta difference between Z690 and Z790, again, all of the motherboards are going to have higher scaling for Raptor Lake in relation to the memory divider, and for Apex for this generation, it's going to be very, very good because, of course, that is a it's a 1 DPC, 1 SPC based board, right? So you're going to have very, very good scaling. All right. See right here? Oh, that's good information. DePoets is noting that he's saying that he found specifically in Star Citizen they optimally needed to disable the E-cores. So again, that is an option you have. We talked about that actually in our 12th gen stream overclocking, where specifically we also talked about that enabling E-cores also actually adds a certain amount of voltage because there's a direct link to the P-cores and to the E-cores. So you actually can reduce actually a little bit of the voltage and when you also disable E-cores, and that also allows you to sometimes scale up frequency. The way that I usually like going about it, if you're going to do it, is to create a different profile. So essentially have a different profile in the Uefi, one with like maybe P-cores enabled only, and then another with, P-cores and E-cores enabled, and then another with P-cores disabled, right? If you wanted to have different kind of permutations, right? Let me just see right here if there's any other questions. Chat, did Deja answer if we can use 4 DIMMs on DDR5? Yes, of course you can use 4 DIMMs. There's no issues with 4 DIMMs. I'll show you actually some results already that I've done. I can show you 4 DIMMs running at 6000 MT, which is quite impressive. That's actually better than the standard than you already had for Z690 and for 12th gen. But again, the important thing is that there's no XMP, so just keep that in mind. There is no 4 DIMM XMP, so you have to kind of really understand that. And if you don't understand that, my recommendation is watch our DDR5 Insights live stream video that we did. Check out our DDR5 Insights post. I'll also try to explain a little bit more about that here if you really feel that you want some more insight into that. But this is nothing new. There's always been a difference between your different actually types of configurations, whether you're talking 2 DIMM configurations or 4 DIMM configurations, right? All right, so we're in the UEFI. Let's go with just some basic parameters. Let's load everything up. We're just going to go with F5 defaults, guys. We're going to keep this from the purest perspective, so we're going to go and we're going to enforce all the limits, and we're going to check those corresponding values, and we're going to load up into the operating system. So let's go ahead and get into our OS, and we're going to kind of just check to see what it kind of looks like, and from there we'll actually go into the overclocking. Okay. So I'm just going to give that a second. Actually, it should boot up there pretty quick, so I'm not going to change the window. Well, that's fine. I'll just change it a little bit back and forth. 13900 great. Is there any secret you can share how to get good good silicon so the P score will be good? No, I mean, that's silicon variance. And also don't worry about the scores. So many people misinterpret the scores. The scores are our own internal value registers that we use based on polling of information. So while it's relevant, it's also not really relevant to you. It's really more relevant to us in the internal machine learning algorithm that we have in place that defines information for the Asus AI overclocking parameters, right? But if you're trying to hunt for a specific value, you're never going to be able to get that value unless you bin, right? You literally have to kind of just go through CPUs if you're trying to kind of hit one. But the more important thing is actually, I think, having a better understanding of how to performance tune and how to work with what CPU sample you have, right? I think that's, to me, that's the way that I look at it. But, if you have a different perspective, that's maybe just how you decide that you want to approach performance tuning. Okay. All right, guys, we are in the UEFI, and I didn't see if anybody in the comments could let me know if they're fine if I keep it there in the bottom right-hand corner. Does that work for people? Or if you guys, would it be better if I moved it over here in one of these other kind of sections? I think it's fine right there in the bottom right, right? So if I can just get a little bit of feedback on that, that would be great. Okay. All right. Go ahead and get my wireless there. Make it a little bit easier for me here. It should be, is it this one? Oh, there we go. Okay. All right. That's a little bit just less work for me in terms of cabling. Okay. All right. So at this point, right, the easiest thing that kind of I recommend in terms of kind of doing this performance baseline is just open up your XTU. XTU is, of course, free. You can go ahead and get this directly from Intel. It's their performance tuning utility. Keep in mind that there are going to be some registers that you may have to go ahead and change within the operating system environment to be able to actually access the MSRs, because there are some restrictions in Windows 11 for some security purposes, so do keep that in mind. So the main thing that you would want to do is that when you open this up right here, you can actually see that it'll actually give you a full kind of breakdown of your values, right? And so what I mean by the values is actually how the actual multipliers are set based on the cores, right? And so here we can see, like, when we have to a kind of pretty much an all-core working model, right? We have 55, and then you can see as it goes all the way up, it's getting up to 58, and then it's getting up to 58. So 58 is essentially on 1 core or on 2 cores. Now there are some other factors that of course will potentially limit that, as we can see right here within the turbo boost power window, right? The short power max is also defined, where we can see that that's limited to 253. So when we're talking about overclocking, overclocking allows us to actually extend performance limits, not just by modifying these ratios, but also by actually adjusting the parameters that the power is looking at, right? In terms of that power envelope, we can make adjustments to that, which also helps us sustain higher boosting activity, which is very important, right? If we can increase those limits, then when we increase also the frequency, that also allows us to make sure that we're seeing more sustained frequencies at those higher values, right? Now, if I go over here, you're also going to see I have gone ahead and set the monitoring window to 30 minutes. This is my preference as far as what the actual kind of information that I like to kind of look at. So that would be my recommendation. And in terms of kind of the values, there's a lot of different values you have available to you. You can see right here, you can actually select all of them, right? But you can have pretty much almost every value that you want. I don't worry about all of these values. You don't really need them all. The ones that I like to really kind of keep a focus on is you got package temperature, which can be useful, core voltage, CPU utilization, but I sometimes will just end up liking opening up my task manager for that purpose if I need to look at that. So I'll sometimes have it open like this, but you can go ahead and monitor it there. The max core frequency, which is going to be useful, and you can see right there that it actually gives us a min and max average. So that is going to be reported to us. I might drop down the resolution, guys, if it makes it a little bit easier to see. So if you guys can let me know, and I can see if I can adjust that. Okay. Package TDP, and then right here, whether you're getting any type of thermal throttle, temperature, I usually will monitor between 1 to 4 cores. So you can see right here, I've gone ahead and done primary P core 0 and P core 1. And then you'll also see that XTU now has this new little readout, and it will actually show you the preferred cores, right? You can see with little stars. So I will usually then monitor those cores as well from a temperature perspective, right? So, and frequency. So we can see again, P1, P0, P1, and then I'm also monitoring, you can see right there, P4 and P5, right? Okay. And then, down here, right, I'm also doing what? Power limit throttling, current limit throttling, motherboard VR throttling, right? I'm just checking those, right? So that essentially are kind of the values that I'm looking for. Okay, so Tech says it looks fine. Great. Okay, so I don't need to put it in. I don't need to put it in 720p output. Okay, so great. So now let's go ahead and just do a little bit of a test on how we can kind of go ahead and check for some of this base information before we start the overclocking, right? So if you want an easy test for everybody that's kind of free, you could of course use something like Cinebench if you want. I like using a little bit more of a test that actually has a little bit more instruction sets. So Geekbench is actually pretty good because it throws actually a little bit of a spread across, right? We're using a few different instruction sets. We're doing some light threaded workloads. We're doing multi-threaded workloads. We're doing a little bit more than just kind of either going for this heavy multi-threaded load, or we're going for this single-threaded load, right? So if we go ahead and now run this benchmark, we're gonna go ahead and let it kind of run through. And now if I want, what I can go ahead is while that's running through, I can now start to kind of just keep an eye on some of this information. And if I wanted to, I can log this to look at it later if I want to kind of look at that information. But right here, we can start to see recent maximum, right? If we kind of hold right there, we can see that it's 5.54 gigahertz, right? That's our recent maximum, right? And then it'll also kind of give us the average, right? But that's important to keep in mind, that 5.4, we can see we got up to 5.6, right? And technically it should be able to get to 5.8, but under the forced Intel defaults, that 5.8 is going to be on that little bit more conservative side as far as probably seeing it peak up to there. We can see right now we just got up to 5.7, right? So that 5.7 is now coming into play. So this is overall just giving us an idea as the workload is occurring, how we're actually seeing that come together. And again, if anybody's kind of wondering about temperatures, you can see we're fine, right? 73C is the peak on the package. And that, of course, is not even representative of course, your average temperature per each CPU, right? So you can see right there, 73, 71, right? So we're fine in that regard, right? And if we move over to the other kind of P cores, just to check out some of those, that's 5.71, 5.51, right? So we can see kind of what's going on there, right? So overall, pretty straightforward. This bench is going to be finishing up in a little bit. We'll let it finish out, and we're going to kind of see what that maximum frequency is, right? Yo Anto is asking, yeah, this is really good. We're getting closer to 6 gigahertz. Yeah, that's the really cool thing. Trust me, we are going to get to 6 gigahertz, which is pretty awesome. 6 gigahertz is actually totally realizable on this platform. So again, we can go back here. See, overall, the recent maximum, right, was a 5.51, right? You can see right there, yeah, 5.8. Sorry, let me go back there. Yeah, 5.51 is our recent maximum. 5.53 and 5.71, right? So I think the highest, right, that we got up to was about 5.71. We didn't actually even necessarily hit that 5.8, right, that is quote unquote defined as being kind of that peak possible, right? And part of that is because some of the power limits and the way things are defined, right? When that you force that Intel parameter, it's going to be a little bit more conservative. If we enable things like, of course, Intel thermal velocity boost, and we will, of course, start to customize some of these values, so just you extending some of these, we would probably open up the power of envelope, and that would be an easy way to just start to give you a little bit more performance if you just wanted to kind of more opportunistically start to hit some of these higher values. But this is, of course, where Asus AiOC can make things a heck of a lot easier for you in terms of taking care of these parameters. So now that we've gone ahead and set kind of that reference in terms of what we know these parameters are at default, if you want, I usually will find, hey, an easy way to kind of store this information if you need to is you can use something like Sharix, or you can use the Windows snipping tool, right? And then you could just take a screenshot, store that screenshot, and then that will give you the values that you can compare. So if I need to compare that information and know, hey, where I'm seeing a before and after, I now have that information stored. So now we're going to go back into the Uefi and enable our next setting so that we can go ahead and see what type of overclocking range that we can get to, okay? Legacy, I'm not sure why you say that. I really feel confident that actually our utility is actually the best motherboard utility that's out there amongst any motherboard manufacturer. We've done a lot of work to be able to offer a utility that's, I think, now quite feature rich, offers a good level of usability. It's actually a UWP surface, which means it's actually quite responsive. It means it doesn't use any active resources when it's not actively in the foreground. It uses less memory than something like GeForce Experience or Discord or kind of other kind of applications in that regard. And, you know, we're actively working on it. If you have legitimate feedback, you know, that you actually want to supply, feel free to leave it back in our Armory Crate Discord, in our Armory Crate forum community that's monitored by our dev team. And I would definitely make sure that you post that so our dev team can review it. You know, we've spent a lot of time and effort. We literally have 20 million active users. So there's actually quite a number of people that are using it right now. And, you know, from version 1 all the way to now to version 5, right, that we're currently at, there's been a lot of milestone releases. So yeah, I mean, if you have feedback, I'd love to hear it. All right, let's get ready to go ahead and jump into the UEFI. Can you please more talk about caching? It is now, I'm not sure exactly what you mean, Yodo. I know I'm going to be talking about the cache tuning function in a little bit, so don't worry about that. I'm going to be getting into that, but first I want to tackle CPU-centric based overclocking. I have two sets. Let me see right here. Somebody's asking. DJ is asking, I have two sets in my cart. Are you certain these will work at 4x16, and what speeds do they work, right? So you didn't say what kits you kind of have, but ideally, again, when you buy 2 kits of memory, right, you are essentially going to always potentially reducing the likelihood of running them at their value. Now, if you're buying something like 2 kits of like 6,000, you can feel pretty confident that you're going to be able to run that on kind of Raptor Lake, right? But if you're talking like 2 6,400 kits, that's going to probably be not necessarily realistic. It's not that it won't be, because the IMC is actually even better than it was in 12th gen, and definitely 6,400 was not anywhere remotely possible on 12th gen in a 4-DIMM configuration, right? But again, if you're talking about frequency, you want to be prioritizing 2-DIMM configurations, because that's where the kits are developed, right? So if you're looking at, 66 to, 72, get 2 DIMMs. That's what you want to be getting on. And don't think that you can just duplicate that and run that, because again, the memory, when a memory manufacturer tunes that memory, they're tuning it based on the NAND, the PCB, the timing, the voltages. All of those parameters are tuned specifically to that kit. And when you then introduce a secondary kit, those parameters that were tuned just for those 2 DIMMs would now be different. And that's what we end up having to do as a motherboard manufacturer. We have to kind of sometimes tune auto rolls in the background that you think you're applying a 4-DIMM profile, but you're not really. We're actually attempting to kind of make that work. And that can be quite a number of other parameters that kind of get tuned to help to enable that. But you still always have to be realistic of that port table that I showed earlier, right? Where there is a difference between, different rank, different density, different population, right? And ultimately 2-DIMM versus 4-DIMM, right? All right, so now we're back in there, and we can go ahead and reload defaults. And we're gonna now go ahead and just enable Asus AiOC. To do that, we can just go right here and we can go to Asus AiOC, and we will be good. Now, the cool thing is right here, you can see this little information. I'm going to move my head so you guys can see that a little bit more clearly, but you can already see that it's giving us actually a good indicator to let us know, hey, under light loading, we're already targeting a 5.9 gigahertz overclock. So we're already seeing that we're actually going to be moving up. But the important thing to keep in mind is that since we're also making adjustments to the power limits, we're actually going to see some more opportunistic tape boosting that's going to be available. And because of that opportunistic boosting, we're actually going to probably be seeing higher frequencies than that value as well. So that is the important thing to keep in mind, is that it's not just the overclock parameter that we're defining. We're also, since we're unlocking other parameters, that's going to be increasing our OC ceiling, right? So if we actually head over here into AI features, we can actually see some more of this information kind of broken down to us. So we can actually see right here, right, that if you guys remember, 5.5 was the all core, right? Now we've gone ahead and moved to 5.6, 5.7 on 5 cores, and then 5.9 on 3 cores. So that's already a nice uplift, because if you remember, the 5.8 was only on 2 cores, and now we have 5.9 on 3 cores. And I can tell you with this configuration, we might already see the opportunity for this to actually jump to giving us 6 gigahertz and maybe some small instances. But if we wanted to bump this up, the easy way that we could scale this out further is this optimism slider right here. Once we actually test for stability, we could just bump this up, maybe go up to like 105 or 110, and that just little bit of additional addition will give us a little bit more of a value that would then step into that next range. And I'll show you a little bit of an example of actually how that would work, so you can actually see how just a little bit of tuning there can help to extend the margin. Okay, now it's also important, some people always ask about voltages. Keep in mind that we do use an adaptive voltage policy. So when I get into Windows, what that means is that the voltage is dynamic, right? When the system's idle, we're not doing a lot, that voltage is going to come down, and it's going to be working very efficiently and effectively. And then when the actual CPU becomes under load, then that's when the CPU is going to incrementally load on the corresponding voltage that's defined. And we can actually see the voltage table as it's defined right there, right? So we are good to go there. So let's go ahead and now save and reboot. And on the next stage, we'll do the XMP, and we're also going to, of course, take a look at the dynamic cache switching technology, and I'll show you actually the values on what we could kind of dial in as a baseline for how we can do some overclocking for the cache or the ring bus if we want to also further kind of improve performance from overclocking the ring bus. Okay. Can you enable XMP? I will enable XMP in a little bit. Can you enable it with 4 DIMMs? Yeah, if you have the right target that you're kind of shooting, right? Again, there is no 4 DIMM XMP, right? That's the most important thing to understand. You are creating your own kit is what you're attempting to do, right? When you buy 4 DIMMs, you should be thinking that you always have to manually tune that, because there is no 4 DIMM XMP. Just because you have the ability to toggle it doesn't mean that actually it is a native 4 DIMM kit, right? But can you do it? Yeah. I mean, I could take out this kit configuration right there, and I can show you actually in a little bit that I've gone ahead and run it. I might have actually, let me see if I have the values right here. Give me 1 second. Let me see if I have it over here. This is going to be, what is this? Is this, that's 72. Okay, so here's an example, right? Can you run 4 DIMM? There you go. This is 4 DIMM right there. 6000 MT, 4 DIMM configuration, right? That's on this Z790, right? So that's a 4 DIMM 6000 MT. That's already better than what you saw on Z690 and 12th gen. That's a full 1 hour stability test with OCCT. That's literally just some basic tuning. I didn't even spend time to kind of tune that down. So you could actually get better than that. So yes, is it possible? Yeah, you can run 4 DIMM. You can run it high configuration. I can show you even the same values, not the same values, because on 12th gen, the values were lower. Generally, you're going to be looking at 4 DIMM was usually going to be between about 52 to maybe about 5600, right? If you were talking a 64 gig configuration. So you can see under 13th gen, the value is higher, right? But again, you have to make sure your kit that you're looking at is the right type of kit configuration. And even then, there is still sometimes some differences between SK Hynix and Samsung, between timing parameters that you may have to kind of tune. And that's the reason why I'm telling you is just that don't think about just purely enabling it from XMP. It might mean that you might have to make a small value adjustment to maybe add more voltage to the memory controller. You might maybe have to make a timing adjustment. And that's because XMP defines timing parameters that are defined for 2 DIMMs. If you're trying to run 4 DIMMs, guess what? The timing parameters, they're not optimally suited to 4 DIMMs, right? Because it's not a 4 DIMM kit. It was not manufactured to run at those parameters, right? So that's just something to kind of keep in mind there. All right, so we are now in the desktop environment, right? So let's go ahead and go back over to Intel XTU. And we're going to go ahead and open up our value right here. See, I'm not asking for a guarantee, but I'm guessing, unlike Alder Lake, where the memory controller was not actually. I really disagree with that. I've been working with motherboards for 20 years. The memory controller on Alder Lake is probably the best memory controller I've ever seen. The scaling level that it offered is just unmatched. There's literally no memory controller in history that's ever shown being able to go from one generation from 4800 to literally 10,000 MT. That is absolutely insane. And even again, this is the last point I want to spend on this, but let's go ahead and type on it, because again, if you really want to understand this, go back and watch our DDR5 Insight streams. We did a lot of time to discuss this and kind of cover it in depth, but this is what you need to understand. A lot of users just don't remember the fact that your default divider, right, is different between one SPC and one DPC, right? So again, if you add in more DIMMs, you're natively making this more strenuous to the memory controller. So the memory controller drops from 4800 to like 44 to 4000 to 36. Now Intel's memory controller in Raptor Lake is stronger, right? This value is not 48 anymore. This is 56, but you still have a drop down table. So there's always going to be a drop down, regardless, always, when you go to a higher density and higher population and higher rank. That is unquestionable. It will always happen. So as long as you're consciousness of that, then you can hopefully understand how you can then approach memory scaling, right? Okay. All right. So when we go ahead and now open up XTU here, we can go ahead and now see, let's take a look at our results, guys. Really, really nice. So look at the results right here. We have 62 all the way on the active ratio on 1, then 61 right here on 2, 61 on 3, right? 59, 59, 58, 58. So you can see we have a huge uplift, right? And then we also have some thermal velocity boost offsets. And so the thermal velocity boost offsets are present, right, to help to align with temperature, right? Because when those temperature values kick in, we can see right there that these are the actual temperature targets. All of these values have already been dialed in. So normally, a lot of people will say, don't use this. And I'm like, we have spent hundreds of hours, thousands of hours creating these permutations, and they're really quite finely tuned to be able to actually be in alignment to give you efficiency and effectiveness while also still accounting for thermal stresses. And you can see that right here where the offsets have been all implemented. And then we have these nice thermal values that are also triggered in place. So as soon as those values are in place, that offset will kick in and help to drop that down. Now, if you wanted them to be more aggressive and you got more thermal headroom, then you can go ahead and adjust those. So you have that kind of flexibility to kind of go with that. Now, if we go ahead and let's back over to our Geekbench, right? Let's go ahead and see now kind of what some of our values are right here. All right, so right here, and again, D. Jockwith, I'm sorry if I'm not saying your name correctly. If you have more questions, please join our PC DIY group. Post your question there. I have no problem following up with you there in the group. And also read our DDR5 Insights post, which will also maybe help you better understand some of these points as well in terms of understanding that. But if you're buying memory right now, like I said, my recommendation, if you absolutely for some reason have to go with the 4 DIMM, if you want the kind of highest level of assurance that you can have confidence in having it work, I would not go over probably 6,000, maybe 6,200, but I wouldn't go over that. You're shorting yourself quite a bit because, as I'm going to show you here in a little bit, 7,000, 7,200 is the new normal for Raptor Lake. So for me, it really doesn't make sense to be limiting yourself to a 4 DIMM configuration unless you're running, I don't know, like you're going to run like 120 gigabytes of memory or something like that. It doesn't make sense. So let's go ahead and now run this. We're going to launch Geekbench, and from here, we can go ahead and start to see, of course, some of our temps and our course frequency. So right there, we can see, of course, now 62 degrees. It's gone ahead and started the test, right? And there we can already see a higher value than before, already kicked off at 5.79 gigahertz, right? Temperature as it's ramping up right there, still tying 42. But let's look at the frequencies, right? And here, this is when you want to kind of just start tracking the frequency as the application is running. There we can already see 5.75, right? 5.79, right? So we can already see that boosting is kind of kicking into place, right? So we can already see that nice kind of uplift in terms of the clock frequency, right? And of course, keep in mind that, of course, different loads, right, are going to hit differently, right, depending on what you're doing, especially gaming. Here, this is actually going to be a bit more stressful than gaming. So the next step is actually we're going to run a little bit of a game in the background and do a little bit of a load test to actually see what kind of the frequencies might kind of look like there in a little bit, right? Simon is asking, should we change the load line calibration? You don't have any reason to change the load line calibration. A lot of users will sometimes just start to change stuff because they think that they should, or there's old logic that people put in a post somewhere on Reddit or something like that saying that you should do this. We actually have really good auto rules, and the auto rules are written by our performance R&D team to essentially align with the values here. So if you do take advantage of like the ASUS AiOC, you don't need to change the LLC. We've already kind of matched the LLC to the corresponding values that have been defined. Really, the main thing that you would want to start to adjust is going to be if you want to either bring down or adjust maybe the multipliers, maybe go in and enable the dynamic cacher technology, right? Or maybe you also want to go ahead and maybe adjust the optimism scale, optimism slider, which I'll show in a little bit, but you don't need to worry about changing the LLC value. The LLC value is also going to be most representative of the load types that you're going to be running. And the one that we balance is quite good for kind of an overall workflow scenario, kind of gaming scenario. So you don't need to worry about changing it. So again, if we take a look right there, let's take a look here at our, our frequencies, right? Recent averages, right? 5.75, and then, yeah, 5.79, right? So overall, nice little kind of bump in there. And again, these would start to kind of be higher as we kind of started to push the envelope depending on what we're doing. So the next thing that I actually would want to do is, let me see if I've got my end walker right here, right? So now let's go ahead and simulate a little bit more of a kind of workflow scenario if we were actually gaming. So let me go ahead and go to a windowed mode right here. Now this is going to play around a little bit odd because the thread director does do some foreground and some background loading, meaning that kind of when something is in the foreground, it prioritizes what's in the foreground, right? But let's kind of go with that. So we're going to clear that out. Actually, let's clear the data right there. Okay. And we'll go back there. All right. Okay. And we're going to go ahead and now load this up here. And this is just kind of, like I said, an assessment and to help us to kind of understand the performance, right, that we have when we're kind of in a more kind of gaming workload scenario. And again, when people are kind of talking about thermal performance, this is where I can show you, again, we have it even overclocked, right? But we're gaming, and so again, we still have that thermal headroom. Now, of course, if you were running something like Blender or a professional 3D application, the thermals are going to be very different for that, especially overclocked, than if they would be for your gaming. But if you're talking about web browsing, gaming, light editing and photos, general desktop use, general web applications, there's no problems. You can thermally control that pretty well with a wide number of coolings, whether, like I said, it's a 240 or 280 or 360 AIO, or of course, if you've got custom water cooling, no issues right there. So actually, I'll let that run a little bit longer, but let me go back here to XTU, right? And again, we kind of start to just take a look right here. Let's see where we're at. So there we can see we're peaking up. We're at, keep in mind though, we have, of course, all those voltages bump up the frequency, and we're still right now, the peak that we've gotten to is 86, right? But that's, of course, not representative of even our kind of average temp, because keep in mind that that'll kind of go up and down, right? And there we can see 76, and on there 78. And of course, there's going to be a little bit of a drop as it kind of goes from one scene level load to the other. 5.1, 5.2, 5.75, right? 5.79, right? Okay. So we're just going to go ahead and just let that run for a little bit. And we'll kind of go from there. And then the next step is, like I said, I'll show you how you make the next level adjustment to go into the optimism slider to be able to go ahead and bump up a little bit. Hopefully the goal is we can see if we can get up to maybe about that 6 gigahertz marker to see that actually reflect at least maybe one time within the game kind of scenario. And we're also going to go ahead and enable the Xmp Profile. And then we'll also go in and make the adjustment to the cache as well. Okay. So is somebody's asking, is high daily use for gaming 1.45? Now keep in mind that's actually a really good point, right? So somebody's asking about voltage. So when we talk about voltage, this is not like a static voltage. A lot of overclockers that are old school overclockers will use a static voltage because it's easy. It's not complicated like trying to define an offset or a voltage frequency curve. But the advantage of what we use here is an adaptive voltage means that that voltage is only peaking under certain requests in terms of the frequency as it moves up. And so that means that you're only seeing small instances of that voltage actually going up to that. So you're not talking about 1.45 where like 1.45 is consistently held, right, across the entire duration. We actually have that frequency and that voltage drop, right? And it will go up when it's under load. And so that means that actually from an efficiency standpoint and from an even lifespan standpoint, if you are going to overclock, using an adaptive voltage and a voltage frequency curve is you're much better off, right? If you're talking about not wanting to sustain that. Now, if you were manually overclocking with a static vid, I wouldn't advise running a 1.4 vid consistently because it's going to consume a lot of power, produce a lot of heat. It's going to cause voltage aggregation. It's just not a smart way to overclock. But there are some people that are like that. They focus really much on doing that, right? But that's not the case, right? With that. So again, if we actually go back here to our, am I tracking kind of the voltage here? I can track the voltage, right? And we'll take a look at that kind of voltage, but we'll see that the voltage will be going up and down, and actually you're better off kind of looking at the average, right? So instead of just looking at the peak, you would really want to kind of look at the average when you're running this for like 30 minutes, and you would actually find that the average is actually lower than the value that you think it is. And so this is where a lot of people, sometimes they'll see that there's a voltage value that's set, and they think that's the voltage that's being run, and that's not really accurate, right? Just because, like I said, it comes up, it goes down, it comes up, and it goes down, right? So ADuck is saying, is this CPU using a Ryu cooler? No, I'm using the new Ryu 3 cooler, not the Ryu Jin. So the Ryu Jin is the one right here next to me, right? So that's, that's this one right here. This one that I'm using, I showed a little bit earlier, this is the brand new Ryu 3. So this is actually even a little bit of a higher performing cooler. This is an engineering sample, but this is our next gen cooler, which is based off of the 8th gen Asetek based pump design, and that one's the 7th gen based design. But they're both great, and they would both be no problem in terms of cooling, you know, a 13th gen. Okay. All right. So somebody's saying, I wonder what the speeds will be like on the 13900KS. We can't comment, right? I know Intel says that they'll be looking to release another CPU, but I think the whole point here is that it's showing you that there's some already margin that's available within the CPU, right? If we talk about overclocking, right, you have a little bit more room. Sorry I was a little late. No worries, man. Feel free to go ahead and watch this on demand afterwards, and thank you for joining us on the stream regardless. And if you're not part of our ASUS PC DIY group, feel free to go ahead and join us. The link is in the description. I'd love to have you be part of our community, right? So let's go back to that voltage again so we can kind of just see what we've kind of been going back and forth at. So again, you can already see that average is actually staying pretty close, actually closer to about 1.235, right? So you can actually see that right there in terms of that voltage line, right, where it's kind of going up, it's kind of going down, up, going up, going down. And so that's, again, where even though you saw that 1.35 being the marker, that's not realistically what you're actually seeing being fed. And that's because we do not use a static vid, right? We really worked very carefully with our performance team and then Intel's team to make sure that we're leveraging kind of the best options in terms of kind of efficiency, as much as you can be efficient when you're overclocking, because when you're overclocking, of course, you're pulling more power, you're producing more heat, but you can do it in a more intelligent and sensible way than kind of just cranking all your cores and cranking up the voltage and going to like an extreme, load line calibration value, or even some like users will force all the phases to run like at a high value, like they'll force them to run all at extreme, which also doesn't make sense. It's not very thermally efficient, right? You're consuming a lot of power for no reason. But let me go ahead and drop out of this because I had it set to loop, so I don't want it to kind of keep going right here. And just again for reference, if I was to close out of this, let me go ahead and close out of this really quick here. If we go back over here, I can show you if I open up CPU-Z. Now, you could do this with HW Info. I've got HW Info here. Different people have different utilities that they like to use, right? But you can see right here, this is the whole point of also what I'm trying to show. So if you actually take a look at the actual frequency, now this is always a little bit tricky because literally running a utility and then showing you is also going to kind of influence its value. But if you look right there, you'll see our adaptive voltage policy and our dynamic loading implementation, right? Excuse me, the dynamic loading nature, along with the adaptive voltage and the per core overclock, shows you see how it's oscillating back and forth. So you're not consistently running that voltage, right? You can see right there, it dropped below 1 volt. And then when it needs a little bit more, it drops up, it goes up a little higher. And then when it's into that gaming load, it then peaks up, but it's going to keep going down. This is why it's so much more efficient to use this. And this is why we also tell users, take advantage of the ASUS AiOC technology as a starting point, because it's already so well tuned that then if you just want to be able to tweak it a little bit further, you can do that, right? So anyways, that takes care of that there. So let's go to now the next step, and we're going to go into the next step for the Uefi and make a little bit more of an adjustment, okay? Let me see. Can you put into high performance and power option Windows look? No, I wouldn't recommend doing that because that, again, that's self-defeating. The people that like to force power states like that, it to me doesn't make sense because you're compromising the overall efficiency of a platform, right? So the moment you start forcing certain power envelopes like that, you're restricting the frequencies, right? Excuse me, you're forcing frequencies to run at a certain parameter. So for me, I like efficiency. So I'm not going to do that because I don't think that there's value in you doing that. If that's something you want to do, you want to change your power profiles, go for it. But I can also tell you that does expose you to more issues in terms of, like I said, power consumption and frequency considerations that I don't think are sensible. All right. So Clay is saying I'm wondering about 13 gen Z790. I don't actually think that pricing is a factor in that regard. I think the feature set is quite justifiable if you really feel that you're limited in terms of price point. I mean, the pricing is pretty good. If you go down to, we have tough gaming motherboards that are starting in the mid 200s. And keep in mind that the feature set is very advanced on Z790, right? I mean, you're getting PCI Gen 5 support, you're getting 4 M.2 SSDs, you're getting 20 gigabit USB, you could be getting Wi-Fi 6E. So you can't even make kind of comparisons sometimes to even boards from 3 or 4 years ago because the spec isn't even remotely close. The power delivery designs are significantly higher end, right? You have support for so much higher end specifications. The boards are inherently more complex. And this is the important thing that a lot of times media don't cover sometimes in the discussion, is they just talk about performance, and that's fine, but you really want to talk about the features and the functions and the experience that you're going to have, right? If you're coming from a board that has like 1 M.2 slot to a board that has 4 slots, to a board that didn't have an internal USB-C header, to a board that didn't have, 3 USB ports on the rear that were Type-C, that didn't have 2.5 gigabits or Wi-Fi 6E, those are all factors, right? But our Z790 lineup, it's priced pretty nicely, right? I think, again, starts off in kind of the low 200s, and then we'll go all the way up depending on the class of board that you're looking for. We have first look previews on our entire board lineup, and we did a full in-depth live stream yesterday that covers all the boards. So if you have questions, check out that stream, Clay. Hopefully that'll help you better understand what you're looking at. And if you really want to save money, buy B660. If you don't care about overclocking, just buy B660. B660 boards are even cheaper, and you can run any 13 gen series processor in there. You can get something like a tough gaming B660 board or an ROG Strix B660 board, and you're good to go, right? Plus, you got DDR4 on Z790R B660 as well. So let's head back over here into the Asus AiOC. The next step is if you wanted to go ahead and now fine tune this a little bit further, we can go down here, and this optimism scale, you can go ahead and adjust this. So again, if you were noticing maybe that value, maybe you test everything and it's not stable, right? We work really hard to have this value across hundreds of samples to kind of be tuned to be in a high probability of success. But let's say it maybe wasn't stable, then what you would want to go ahead and do is reduce that. Maybe reduce it to like 90, 95, right? You could do that. Or the inverse. If you notice, hey, I want to see if I can get a little bit more, go ahead and raise it up. Go ahead and let's go up to now 105. And now this will allow it to be a little bit more aggressive at the optimism scale to see if we can get even a little bit more performance headroom out of the ASUS AiOC algorithm, and that will make all those changes for you. Okay, so the next thing is, now let's go ahead and now I'm pushing the envelope because I'm testing an overclock that I haven't even tried here, but let's go ahead and now also enable our XMP. So if you guys don't know, a really cool feature that we do have inside of our Uefi is the SPD information. It will allow you to check the actual memory that you have installed in your system. So we can see right here, we do have an XMP kit of memory. This is 7200 MT. This would not be realistic unless you were generally talking about like something like an Apex board or a mini ITX based board, so 2DIMM board, and an outstanding memory controller to be able to run this on Z690 and 12th gen. But here, this is going to be pretty easy to go, and this is on a 4DIMM enabled motherboard, right, where we're going to be running this 7200 MT. So you can see that information from there. In terms of enabling it, of course, all we have to do is we just go over into our enabling the Xmp Profile. So we're going to go ahead and enable the Xmp Profile. There we go. And now if I wanted to go ahead and test this, you don't even need to boot directly into the operating system. We do have an integrated Mem Test, so you can go ahead and click on this button, and that will actually reboot you straight into an actual Mem Test suite that we have built into the Uefi BIOS. So that's a really great feature that if you want to be able to test the memory right off the bat, you can do that without even having to boot into the operating system. And it will run up to 4 passes. If it passes through, then you can go ahead and be that route, and you know that's a great option for you. So I would go ahead and recommend that as an easy way to you know, test your system if you want to go through that route. But you know, for time expediency, I'm not going to run through this whole stress test, so I'm just going to go ahead and cancel out of that. We're going to end the test. Oh, sorry, end the test. And from there, you then do have some other options that you'll see here, like you can do a RAM benchmark. So if you actually wanted to see your bandwidth, you could actually go to the bandwidth and you could compare that to, you know, your standard value to your higher value. You could essentially do this all without having to go into the operating system and crash or do any of those things. So it's quite nice, right? But I'm going to go ahead and exit out of this and now get into the operating system. And you can actually see how long it would take to train. So we were running at stock. We were running at the default memory divider support. And now we're going to go ahead and kick into the 7200. Yeah, Corsair Slop is saying Memtest is good for quick stability. Yeah, so I use that as my initial primer. You can see how quickly the 7200 trained, right? Literally, we're just with the launch Uefi. We haven't even done any performance optimizations, which we'll be doing over the coming months. And you saw 7200 just trained just like that. Bam, we're already now in the operating system, right? So there you can go. We see we literally booted in. Now we've got our overclock in play. We already got that per core tuning up to that what 66162 gigahertz and 7200 mega transfers on the memory, right? And that was all in what, less than like a minute, right? Pretty awesome. I have the Z690 Extreme compared to the Z790 Extreme. They're both fantastic boards and they're going to be very similar. The power delivery, the overall 10G, the Thunderbolt. There's a couple of small differences. You can check out the first look preview on the Maximus Extreme board that we have up if you want to kind of see some of the specific differences, but I wouldn't be worried about changing the board, of course. Z690 is a fantastic platform. It's fully compatible with 13th gen and you'll get a great experience. So you don't need to worry about changing it out, okay? Dead BC77, JJ, should I toss out my Maximus Z690 formula? No, it's fantastic. The Z690 formula is fantastic. Plus, we're not going to make a formula for this generation. So, you know, I would definitely keep it. I love that board. It's a fantastic looking board. So right here, there we guys goes. We can see, let's head over to our memory, right? Sorry, let me go back over here. And where is it? Back to the XTU. Running the 13900K on Z690 will allow it to run higher frequency memory. Yes, you will be able to run higher frequency memory, okay? And XTU also, if you wanted to then represent the memory, yeah, I believe there is a tab that you can also have the memory be logged at one time too. So yeah, you can see right there, like if you wanted to go ahead and have your memory be listed, you could have your memory be listed. I'm wondering if I forgot to change a value there in the Uefi. So let me go back and actually double check that, because it did show 4800 there. So let me go back and double check and make sure that actually the memory is present there. Matt G is going, what's upgrade to Pro? That's just the more advanced suite. So we partnered with Passmark. So they actually have a more advanced version, which offers some additional functions. If you're just looking for basic memory testing, you're entirely fine. But if you want a more complete suite, then there is an upgrade option that you have available to you. But it's not required. Like this feature is present within the motherboard. So it's not something that you have to go through and worry about. Okay. Oh, there we go. Okay, so let me go back and now get that in place. There we go. Okay. Let me see there if we have any other questions that came up there. Okay, looks like we're okay. So we're rebooting back through. Like I said, training, in my experience, depends. Of course, 4-dim training is longer than 2-dim training, but in most situations, the training is going to probably not take you more than I'd say about probably 15 to about 20 seconds as far as the normal kind of training timeline. So you should be pretty straightforward. Yo, we need more Prime Z790 stock out here. Yeah, rest assured, no worries. We're working on that. So you can see the training completed there. It's right around in the target that I told you. Actually, I think that was probably a little bit quicker than I said. As far as, like I said, normally it takes around like maybe that 20 to 30 seconds. That was less than that. And we can see that we have the 7200 trained over from the 48, right? Now we still might, I think, I don't remember if I had the Asus AiOC still enabled after I made that change. So I might have to go back and re-enable that, because an important thing is that we do not overclock DRAM when we enable Asus AiOC. And that goes back to our original kind of point that I talked about, asynchronous based overclocking. We only overclock the CPU. We do not overclock the DRAM, because overclocking both could lead to a higher level of instability, and then you don't know which one is causing your fault. Is it your CPU? Is it your DRAM? So that's always the reason why you have to go back and either you enable your XMP and then enable Asus AiOC, or the other way around, right? But either which way, you have to overclock both, right? You need to make sure to enable both of those as opposed to just doing one or the other, right? What's the motherboard I'm using? The motherboard I'm using is it's the Maximus Z690 Hero. Okay, it's this one right here. My recommendation, though, if you don't want to jump all the way to the Hero, I really like the ROG Strix Z790-E. I think that's a really outstanding board. The Dash F is also a really good value, but actually any one of the ROG Strix boards are a great choice if you want to save a little bit, still get the Asus AiOC technology. You still will also get the dynamic switcher technology that I haven't even talked about yet. So great option, but this is the Hero. The Hero is kind of like the benchmark. I'm always a big fan of the Hero, so that's the reason why I'm using it. All right, so let's go back over here. And there we guys can see. So we can see now we've got the 7200 right there. You guys are good to go. Hopefully, can you see that, guys? Let's go maybe get the magnifier. If I can type. There we go, magnifier. Okay, so let's go right there. Yeah, you can see you got the 7200 is running, right? And so now I've gone ahead. I'm not going to spend all that time to go through and run through the entire Mem Test suite because I've already done that. So let me go ahead and just show you. The next step, if you would want to, my recommendation for doing your memory stress test after you hopefully have done the Mem Test is you can use an application like OCCT. So you can launch OCCT and check your memory. And my recommendation is start with a value of 15 minutes. If 15 minutes passes, then go ahead and expand that and move over to 1 hour. If you can generally pass 1 hour, you should be pretty confident that the memory isn't have any issues. And so right here, you can see this is 1 hour fully complete in terms of the memory passing. I did it literally right there when it was still under the full load, right at the end. You can see that is on the Maximus Z690 Hero, right? The memory was under that full load, 7200 MT. It's the same kit of memory, that Corsair memory, right? So everything is running copacetic. So again, really impressive that Raptor Lake is now affording you the ability to run 7200 memory. Overall, the new average, like I said, is about 7000 to 7200. And then, like I said, a little bit better IMCs, you'll start to scale into 74 to 76. And then, you know, that even better quality will be in that 76 to 7800, or maybe even a little bit more than that. So pretty awesome, okay? So that is overall gonna be that. So if you were then run the memory test, if you're kind of just interested, all you have to do to run the memory test is just click this button. You can toggle the value right here. I like to bump it up to 90%. And if you want to change first that 15 minutes, you would put 15 minutes right there. then click start. And then if you wanted to do the 1 hour, you would then change that back there, right? And then just do 1 hour and then run that. And then you come back to that and you're good to go. Another valuable point too that I would recommend is sometimes if you want to check, you can actually check your DRAM temperature. So the DRAM temperature is logged with an OCCT right here, and you sometimes want to be able to check on that information, okay? All right, so give me 1 second here. All right, so that is going to take you through in terms of that memory. And again, if you just want to check all your kind of corresponding values, you would do the same thing that we did before in terms of course, checking your performance. So again, if you want to kind of load everything up, you'd load this up. Again, Geekbench is a great tool to be able to kind of reference performance because it's memory sensitive, it's CPU sensitive, right? So we can kind of do a little bit of all of those, right? So again, you could use that as kind of your baseline to be able to check that. And again, you could go ahead and run your test, right? And so then you would check and kind of compare and contrast your course performance and you would be good to go, right? Hold on, let me see if there's a question right here that's kind of come up. Let's see, hold on. I have a high-end kit running at 6400 for the Z690 here. I think I could reach 7200 easily with a 3900K. You should have a pretty good likelihood. Like I said, right now with most Raptor Lake series CPUs, we're seeing 7000 MT kind of become the new normal. We're still doing some testing interoperability on Z690 because like I said, there's been a little bit of optimization on trace and kind of signal integrity, where we're getting a little bit more, better kind of signal integrity on Z790. But overall, I would say that your experience will be improved. You can scale beyond that on Z690 with 13th gen if you decide you want to upgrade. But if you're ready right now are running 6400, I'm assuming you probably have like a 12700K, 12900K. I don't think you need to upgrade your CPU. You know, if you maybe had like a 12600 and you've got that money and you want to jump to like a 13600, go for it. It's a really nice jump in terms of really kind of getting you to that next level of performance. So overall, you can see here. So overall, you can see now that we've gone ahead and reached this, of course, 6.2 gigahertz, right, is now set as that peak level of performance, 61, 61, 59, 59, 58. And so you'll remember this has gone ahead and modified that. And if we also want to check this again to compare our values, we can go back to, if I told you guys, right, you can have your kind of screenshot there, right, that you have for your baseline. Sorry, wrong one. Is this our baseline? Yeah, that's our baseline, right? And so let's go ahead and kind of just do the compare and contrast here. So there we go, right? This is going to be a little bit tricky, right? But more or less right there, right? So there we can see there's kind of stock, right? So stock is 55 to 58. And now here we can see what have we achieved, right? 62, 61, 61, 59, 59, 58. And that was all done through the Asus AiOC. We went ahead and adjusted the optimism scale, right, to give us even a little bit more of an aggressive option, right? And we also are still leveraging nice, efficient adaptive voltage policies. We have the thermal velocity boost offsets that are also be present, right? So that's when, again, you can kind of compare and contrast, and you can see this is a huge uplift in terms of just giving you more flexibility. And even though there's a lot of people that are talking about, of course, the temperatures being, right, again, when we took a look at the temperatures right now, at that peak overclock, the highest that we got to was 88. And that's only under that peak, right? And keep in mind that, again, when we measured that under gaming, gaming would actually be lower, right? So, you know, don't be kind of concerned that it's going to be super, super hot in that regard, right? So overall, that kind of gives you a breakdown there. Let's lastly, let's go through, I guess, and enable like the cache functionality. So the next step, right, because we have, of course, remember, we've got now the 7200 mega transfers, right, in terms of the memory, 6.2 in terms of the peak OC. And so now we're going to do the dynamic cache switcher technology, okay? So let's go ahead and reboot this. I'm going to go back into my Uefi guys here. And give me 1 second. Hey, Ultra Precision Technologies, man, happy to have you here. Thanks so much for joining us. Sorry if I missed the stream. What is the safe value for the memory temp? Is it a safe temperature for the same as DDR4 and DDR5? Actually, it is a little bit different. The good thing is I'll tell you is that overall DDR5 is quite good in terms of that. One of the really nice thing is that also all DDR5 modules actually have on board temperature sensors. So DDR4 did not always have this present, so you can actually nominally check very easily across all DDR5 memory. I can tell you that there are some differences. Most memory reviews, if there are memory reviews, they don't talk about it, but there is actually some much better quality DIMMs than others when it comes to their heat dissipation characteristics. And once you get to a very heavy sustained level of load, and so what I mean by heavy sustained level load is you're talking about memory being fully saturated under 70, 80, 90% or 100% almost usage, that's when then sometimes you want to account a little bit more for thermals. From a gaming perspective, don't be worried if you see it when, 45, 55, even 60 degrees, entirely fine. It's not even of consequence. You don't need to be concerned. If you're somebody that's running a more rendering type environment though, in that type of scenario, of course, for best stability and uptime, you would want to try to keep it underneath, generally nominally about an 80 ADC target. It depends. You can actually check the rated specifications for the memory, similar like SSDs, M.2 SSDs. You'll find most of the M.2 SSDs on the market are generally rated for about nominally a 75-degree kind of thermal operating parameter, right? So just check for your memory, and you can kind of work from that perspective. All right. All right, so let's go ahead and let's go to the next item right here, guys. So give me 1 second. I'm going to take a quick drink of water right here really quickly. All right. And the next step that we're going to go to is we're going to enable that cache. So how do we enable the cache overclock? All we have to do is head over here, and we're going to head into thermal velocity boost. Okay. And once we go into thermal velocity boost, right, you're going to see that you have a couple of options, and this is the brand new option right here. You see this one? It says Cache Dynamic OC Switcher. And essentially what we're going to do with Cache Dynamic OC Switcher is to open up the opportunity to be able to essentially overclock the cache, but do it in a very intelligent way. Because normally when you overclock the cache, it is going to potentially affect stability, especially of the E-cores. And because E-cores can be used for quite a number of different background tasks, you ideally want to try to align that overclock to be based on when either they're kind of sleeping or they're not sleeping. And this also will align kind of with P-cores and whether or not you have your E-cores or your P-cores enabled or disabled, right? And so we give you the granularity to control this. So what would kind of be some parameters that you can work with? Well, let's go ahead and show you how this would work, okay? So all we need to do is go ahead and enable this. Actually, sorry, I didn't drink my water. Give me 1 second. Now the current threshold right here, we're going to go ahead and set this to 45. Now keep in mind that this is a little bit where sometimes there's a little bit of a trial and error. You can use this as kind of a starting point for, I'd say, gaming and light kind of productivity applications, but you would want to kind of try out different values. Depending on your workflow, you may find this might need to be a little bit higher or it could be a little bit lower. It just depends on your applications, but this is a good overall starting point, especially if kind of the focus is generally going to be gaming. The next step is, threads to sleep for higher cache gear, right? And so that's going to be allowing us to essentially have those threads essentially not be active so that we can maximize essentially the higher cache overclock, right? So we're going to go with 24, right? Now keep in mind on a 13900K, right, we've got 32 threads, right? So here we want to go ahead and essentially disable those, right? And then under the cache ratio, now we can go ahead and increase this to like 51. And we don't have to worry about voltages. We have auto rules that are in place that will automatically define those for you. You could go ahead and kind of mess them around if you wanted to, but you don't necessarily have to. And then the low cache ratio, we want to be able to go ahead and reset that back down in the event when essentially that current threshold is either essentially over or under, right? So once we've gone ahead and done that, we've now reached essentially a three-way kind of overclock, right? We've got that pretty crazy overclock that we have for the CPU. We have, of course, the overclock for our DRAM, which you can see right there, 7200 MT. This is, of course, showing us light loading 5.9, but of course our peak thermal velocity overclock is actually set all the way to 6.2 gigahertz. And now we've also got this 5.1 gigahertz for the actual cache, right? So for that ring bus. So we've got now all of those overclocks enabled. So let's go ahead and save and exit. Okay. So yeah, Darwinian is saying there's basically 0 reasons left to disable the E-cores now. So yeah, we try to want to give you the best of both worlds, right? So this kind of technology really allows you to still benefit from keeping the E-cores active to give you that best performance when you can take advantage of the E-cores, right? But in scenarios where you essentially can get more benefit from the P-cores and driving that frequency and then driving, of course, the cache, right? Then that's where this is advantageous, right? And so this is, again, where ASUS is really the leader. There's no other company that is spending the time and effort to implement these type of designs, features, and functions for enthusiast tuning. And this is the reason why we really say that, you know, we are the innovation leaders when it comes to motherboards. I know that sounds biased, but really I challenge other companies to show the level of commitment that we've done on the R&D side year after year to give you these type of options and tools from an enthusiast perspective, so that if you want to get more from your platform, you have it available to you, right? So some pretty cool stuff. So once you've gone ahead and done that, right, it's pretty straightforward, right? All you're gonna need to do, again, if you want to go ahead and check everything out, you could go ahead and open this up. If you actually open up the task manager, it's also going to look a little bit different kind of than the norm, right? You'll see that this would start to kind of look a little bit different once we start to do kind of some loading to it, right? But we'll still see all the corresponding values that we have here that we've already kind of made an adjustment to. We have all our adjustments right there as well that are present, right? So we're all good to go. And we have the same monitoring values that we would, again, have in place, right? So again, if you want to kind of rerun, you could rerun. Let's maybe do something a little bit different. I guess we can do maybe a little Cinebench run or something like that. Let's just do single right there. And you could do R20, R23, it doesn't matter. I have R23, it's just the first one that I opened up. I didn't kind of just go from pick something kind of just for whatever, right? So temp's looking all good right there. Looking good. Yeah, there you can see recent maximum 5.94, right? So that peaked up already quite a bit. 5.98. 6 gigahertz. There you guys go. Look at that. Look, we hit that recent maximum. We did actually hit 6 gigahertz. 6.04 gigahertz. So there you guys can see, right? We actually did it. We overclocked. We got into the 6 gigahertz range, right? In terms of actually realizing that. And so again, keep in mind, those values are going to be representative based on the workload. In some applications, you might be able to see them. In other applications, you might not see them. It just depends, of course, on what you're going to be running, right? But you can see right there, look at that, 5.94, 5.98, yep, 6 gigahertz, and 6.04, right? So that's pretty sweet, right? I mean, an impressive platform. And again, you know, this is only single thread, right? But of course on a gaming workload, again, no problems right here. So package temperature, we can see the peak is 74, but the recent average, which is of course what we really want to take a look at there, right? You can see is like 59, 69, whatever. And you can go ahead and then just look at also at per core temperatures. I usually like to maybe metric about 4 of them. So you can see I have 0, I have 0, 1, right? And then I usually also will take a look at my favorite cores, right? So I'll have those favorite cores also in terms of their temperatures, right? But overall, you guys can see, man, over 6 gigahertz, 7200 MT in terms of our memory. And we also have the cache overclocked, right? So overall, pretty sweet, right? That's I think pretty awesome in terms of just overclocking capabilities. So let's go ahead and wrap things up here, guys. If you guys have any other kind of pending questions, we'll definitely do our best to answer them. But let me go ahead and just bring up some last kind of just recaps right here of some of the items to keep in mind, right? So just kind of recapping everything, right? Let's go ahead and just recap, right? 6 gigahertz is possible. We just showed you, right? And in my testing, I've actually done it. I've seen actually 6.1. I've seen over even 6.1 in some applications, right? So again, many of the CPUs on 1 to 2 cores, you'll be seeing 6, 6.1, 6.2. Again, remember that the load matters, right? Whether it's light loading versus heavy loading. Your E-cores can support overclocking between 4.5 to about 4.7 gigahertz. Again, there's a difference in terms of the light loading and the heavy loading. Again, when you play also with that new cache OC switcher technology, that will allow you to go ahead and take the best of both worlds, where you can disable the E-cores to be able to get that higher clock performance from the P-cores, right? But then also, as soon as you want to be able to be leveraging your E-cores, the E-cores can come back into place and you'll get better performance. But you'll also, when those E-cores are essentially dropped out, then you can also make sure to have that ring bus and that cache be bumped up as well, right? Temps under gaming and desktop loads are entirely fine, right? So a perspective of saying that these things run super hot, they're entirely fine. You can run a 240, 280, 360 AIO, or if you got custom water cooling, fantastic. If you're doing general productivity, if you're doing general gaming, no problems. If you're somebody that's a professional creator and you're running sustained, heavy, multi-threaded workloads, yes, you need to make sure to have a big, robust cooler, and you're probably not going to be looking at overclocking, or you're going to maybe just look at looking to have enhanced power limits. So leaving things like multi-core enhancement enabled to give you a little bit more power headroom so that you're more opportunistically boosting, right? But you're probably not going to be doing the same type of setup that we just went over here. The IMC is improved, right? There's a new expectation for DDR5. You're going to be seeing a move from seeing a lot of the CPUs being able to hit that 6,000, 6,200, 6,400. You're now going to be seeing 7,000, 72, 7,400 in those 2DIMM configurations. There is also a bit of an improvement within 4DIMM. As you guys saw, I showed you 4DIMM and 6,000 MT, and I've also showed you 2DIMM and 7,200 MT, okay? And max performance, if you want the best, then you want to overclock the CPU, you want to overclock the DRAM, and you want to overclock the cache. And guess what? We make it easy for you. You can do it with Asus AiOC. You can do it with the dynamic OC cache switching technology. And of course, we have best-in-class XMP memory support. So that gets you covered there. Gets you covered with hopefully some good tips and tricks, guys. All right. Let me go ahead and just see if we got any questions from anybody here. All right. Let me see. What's up with the pixels? Hey, RC Cosplay, thanks for the feedback. So that's not a Ryugen 3, it's the Ryu 3. So actually the Ryu is a different unit. So the Ryugen 3, excuse me, there is no Ryugen 3. We are considering a next generation Ryugen, but not anytime soon. So the Ryugen 2 will be out at the same time as the Ryu 3. So they're two different models. If you want the fully customizable display, then go with that. If you want the pixel anime matrix display, which has been really popular on these boards, then go with that. But also keep in mind that the Ryu 3 also has an 8th gen Asetek pump. It has a different base plate, which is also larger and higher performing. It has more internal liquid, right? It has a different actually 3-phase motor design. So there's a lot of performance benefits too, outside of also the cool new ID design that we have there that actually a lot of people have had. In our polling, we actually had about a 50-50 split. 50% of people like a circular head and 50% of people like a square head. And so we're not changing that. We're keeping both. If you want to go with the square head, go with the Ryugen. And if you want to go with the circle head, go with the Ryu. Okay? All right. Let's see. BMKDNF is speaking of the ISC, what results have you gotten from 120 gigabyte? I haven't done any new 120 gigabyte testing, so I'd probably say check back in a little bit. I'll probably have some updated results that I'll do in the PC DIY group. The kit that I have right now is 120 gigabytes, and also for most of our team, generally those kits, they're not actually kits because there is no 128 gigabyte. But you know, with Alder Lake, you could already do 128 gigabytes at 4,800 to 5,000 MT. My expectation is that you'll probably see about a maybe, you know, a 10 to about 20% uplift in there. So I would say that you can see, you know, maybe 120 gigabytes moving into the 52 to maybe 5,600 range for 128 gigabytes. Okay. Let me just see it here. Casey is saying 1.43. Keep in mind the voltage, right? If we actually go back and also check that voltage, you're just looking at the peak. You actually want to look at the average. You'll actually find that nominally the average probably voltage is probably going to be closer to around 1.25. And the other important part, like I already showed in the past, right, is if we actually go back here, when you take a look at the voltages, right, it's very important that you keep in mind that your voltages, we use what's called an adaptive voltage policy. So adaptive voltage policy is very efficient. So that means that we're not keeping the voltage static, you know, across whatever workload you're doing, which would also cause a higher level of voltage degradation and other kind of concerns, right? So the thing, you know, I already showed this before, right? But if you take a look right here, we're going to see that that frequency is going to go up and down, but that voltage is going to go dropping down. So unlike a lot of manual overclockers, which, to be frank, sometimes they get lazy and they don't want to take advantage of something like a VF curve or an adaptive voltage or even offsets, they just go for a static voltage. We don't do that. We use really the best option for overclocking per core, which is going to be adaptive per core overclocking. So that voltage is going to come down, be nice and light, and only when we're incrementally increasing those bins, those multipliers, are we then adding in that voltage, right? And then once you normalize that, also accounting for the LLC, the actual voltage on average is actually underneath that value set, okay? All right, see right there? Real world performance in FPS and games. What's the benefit from this OC? What can we expect on average? Hey, Bane, I can't tell you that because it really varies so much, right? Like on my workload, I do a lot of different things on my system. I do everything from just decompressing and compressing applications to, you know, of course, gaming to, you know, even web browsing performance. One of my favorite benchmarks, run web browser benchmarks like Browser Bench. You can actually notice some nice performance uplifts, not only from DRAM, but also from CPU frequency. So it really depends. You know, you could be seeing a few percent to you could be seeing 10%. You could be seeing more. It's hard to know. I think the main point of what I'm just trying to illustrate here is the margin that you have available on the platform and also what's possible, right? And so then it just really comes down to you as far as whether you want those performance uplifts. I mean, you're buying an overclocking part, you probably have a good motherboard, you have a nice cooler, so why not take advantage of it? Again, you don't have to if you don't want to. Performance is already fantastic at stock. So if you don't want to do that, you don't have to. But the goal here of this stream is to try to just give you an example of the performance benefits that are possible, right? Somebody's asking, is that when can we maybe see 76, 7800? I can't give you specifics on that. I would stay tuned for memory partners, but definitely as we get ready to get into the end of the year and move into 2023, you're going to start seeing a lot more high frequency kits that are breaking the 7000 MT barrier, okay? Assembling a Z690 13900K and a Strix 4090. Wow, awesome, man. Fantastic. Thanks so much for being Team ROG, Team Maximus, and Team Strix. Make sure to submit your build for our PC DIY Builder Spotlight. If you're not part of our group, make sure to join the group. It's linked in the description. We feature custom builds by builders from the community every week in our normal PC DIY stream. This week we didn't do it because we were doing this overclocking live stream, okay? But that sounds like an awesome build, man. Thank you so much. All right, let me go ahead and just see if we got any last questions right there. Hey, I have a 12900K. So let's see right here. I have a 12900K and an Asus Z690E motherboard. What are the best settings on the motherboard for my processor without overclocking? Well, if you're not going to overclock, that would even be DRAM. Xmp is overclocking. So are you not even wanting to run Xmp? If you know, and best settings, I think also are very dependent. If you're talking about the best settings for lower temps, that would be different than the best settings for performance, right? If you just want stable reliability and you just want great performance and you don't want to worry about overclocking, just do F5. Literally, don't make any changes, load F5, and that's it. Now, if you bought higher frequency memory, that will mean that the memory is not going to be running at its rated profile. So you would want to probably at least enable XMP. Now, there's one option, and I can show it to you one more time. I already showed it to people in the past. There is an option in the Uefi BIOS that is called Enforce All Limits or Enhance kind of limits. And this just allows kind of the CPU to have a little bit more power headroom available to it to have more aggressive and kind of higher performing boosting parameters. I would recommend leaving that enabled as opposed to forcing the Intel defaults because you have a very good motherboard and I'm assuming you have a good cooler. So for me, you don't have to kind of tune more than that, but I would at least use those parameters and you can have a great experience from your system, okay? Have you gone into the average power draw on the 13900K when you're doing this? I haven't done that, but I did already show that a little bit earlier. So if we go back here and you do look at that, you do have that information available to you, right? You can go ahead and pull that up. It's not really, again, that much of a factor because you're not talking about crazy power draw when you are, sorry, let me actually go back. I'll go back and show it here in a second. But you're not worrying about kind of crazy power draw when you're under essentially a nominal workload, right? Essentially a load that's not super crazy, right? When you're talking about kind of like gaming related workloads, it's not going to be anywhere near the high power envelope that you see under these multi-threaded stress tests, right? So when you see kind of like, you know, the communication saying like, oh, 300 watts, okay, that is legitimate if you're going to be running Blender. But if you're talking about gaming, or if you're talking about other scenarios, you know, you're talking you're talking considerably. You could be talking about half that. You could be like, 90, 125, 150. So the overall power envelope is quite reasonable. That's the reason why I said, keep in mind, I'm using a 650 watt power supply, right? So even when I was running the game load test in the overclock situation, that was on a 650 watt power supply. Okay. So you don't have to kind of be super crazy in terms of kind of what you're doing. It just depends on what your workloads are. Now, again, if you're in a professional workflow scenario, it's going to be different. The power draw will be significantly higher. But if you're just talking about gaming, desktop productivity, things along those lines, it's not something that I would be super concerned with, right? Stardust is saying, what are your thoughts on power limiting, but also overclocking? Is that counterproductive? So power limiting, I'm assuming that's kind of like what we showed in the very beginning when we showed the very first performance example where we did force Intel defaults. That wouldn't even be power limiting. That just means that we'd be adhering exactly to the quote unquote default rated spec, as opposed to also Intel does technically allow for an increased power envelope and that to be applied to get better performance. For me, in my perspective, I think that that is an option that you should at least maintain because you're getting that performance, especially if you got a good motherboard and a good cooler. There's no reason to not take advantage of that, especially because, like I said, most users are not running sustained heavy loading. Now, if you're talking about something like undervolting or stuff like that, I don't know if that to me necessarily makes that much sense, because I think that the part is actually already pretty efficient. It's nominally actually quite good in terms of the overall kind of power envelope under normal desktop use. So I don't feel that there's a heavy requirement to do that. So I don't think you really should be kind of going in power limiting. Now, there are some cool options in AIOC. If you did want to maybe have some sort of targets, like you want to have like a temperature target, you could even dial in an overclock that would be temperature target based. But if you remember in the values that we showed you for the thermal velocity boost, we already predefined thermal velocity boost characteristics that have temperature targets. So only if the CPU is under that temperature will we attempt to ramp up to those additional frequencies as well, right? So that's already kind of built into the Asus AiOC logic. But if you're talking about from a baseline perspective, there are some options, but I really don't think that it makes sense. I think that, if you're adopting into a 13 gen series processor, you want to get the performance that's at least advertised. And I think I would keep it essentially at least at those stock parameters. I wouldn't go about kind of doing customized power envelopes or, undervolting or things along those lines. Okay. Board Erica says, do you run Prime 95 as a hobby? No, I don't like Prime 95. I don't see the point in it. It's a synthetic based workload. It does have an actual real world value, right, for people that are actually looking for Pi, right? But from a stress testing standpoint, for me, I like to use applications. And the reality is applications can sometimes actually be more stressful in terms of how they exercise the entirety of the CPU and the platform, exchanging memory across the storage bus, the memory bus, the cache, the CPU, working across the GPU. I prefer real applications as far as kind of being my benchmarks, but I do use a couple of kind of key utilities to stress. So my kind of default preference is I'm a big fan of OCCT, and then I can follow that up with a couple of other stress tests, whether that's going to be an AIDA64. I still actually like Sysoft Santra. Passmark burn-in test is a good utility as well. And Prime 95 does still work as a good test, and especially if you want to break it down between, different FFP sizes, it is still a good stress test. But the important thing is it's not representative of really any normal workloads for normal users and gamers, right? That's the important part to keep in mind. Correct, yeah. BMKDNF says, crazy power draw is mostly reserved for us prosumers and develop that compile large code bases. Yes, that's right. If you're in one of those segments, yeah, you are going to be consuming more power, but you're also probably running a more nominal kind of clock. You're not probably overclocking as well, so the power envelopes are not going to be as much of a concern. Do you know what runs hotter, is a 12900K as a 13900K? I would actually say that they're going to be pretty similar, and in some scenarios, actually, I'd say the 13900K might be a little bit kind of smoother in some regards, right? But it's going to be pretty similar. Okay. All right. We'll go ahead and wrap it up with last question here. Mr. From Germany, all the features that ASUS proves. Sorry, hold on. Let me just click that so I can read it. Hi from Germany. All of the features that ASUS gives us proves me right to run all my systems since 12 years on ASUS high quality motherboards. Man, thank you so much. I really appreciate that. And if you're not part of our ASUS PCIi group, I'd love for you to share your system in the group. So it's linked in the description. But really, thank you for your support. Without amazing members in our community and users, we wouldn't be where we are. So that's the reason why we're doing these streams. Hopefully, give you better insight into understanding the features, functions, and designs that we have. All right. So last question. Jester says, says, in terms of an AIO cooling for the 13900K, is it possible to use a larger cold plate, one made from threaded ripper, larger size CPUs, or for better cooling, or is a 420 size? Okay, so long story short, you're just saying if like you have more contact, right, more of a surface area. I would say if you really care about temperatures, go to custom water cooling. This new Ryu cooler that we showed actually does have a bigger base plate. It's an 8th gen base plate, so it is larger. But you don't need to do that. You don't need to go. I think really if you get a nice 360 like the Ryu Jin or the Strix LC or the Ryu, you're going to have great cooling performance. You don't have to worry about that. But if you really kind of super care about the lowest temperatures, then of course water cooling is your friend, right? All right. That wraps up everything. If anybody has any other questions, feel free to go ahead and join our PC DIY group. It's linked in the description, so you guys can go ahead and join us there. If you guys are catching us on demand, hopefully you found this content interesting, useful, and relevant to you if you are going to be performance tuning your 13th gen series processor on your Asus Z790 series motherboard. Keep in mind that the Asus AiOC technology that I did talk about is only applicable on Asus AiOC enabled base motherboards, but all the other things that I talked about do kind of hold true in terms of the platform as a whole. Okay, so Asus AiOC is present on our ROG Maximus series, on our ROG Strix series, and on our ProArt motherboards, but is not on the Prime and is not on the Tough Gaming models. For those, you can do manual tuning either through the Uefi, or you can also take advantage of it in XTU. All right, man, take care, take it easy, enjoy the rest of your day. Best of luck with your builds, and hopefully I will see you guys in the Asus PC DIY group. Take care.